When humanity raises its eyes to the night sky, it is not merely looking at scattered points of light, but at its own reflection cast into eternity. Each starlight shimmer is a message from the past, a photon that has traveled across cosmic seas for tens, hundreds, even thousands of years before striking the human retina. To gaze at it is to stand on the shore of time and feel the pull of questions as old as consciousness itself. Could we, one day, return the gesture? Could we leave our solar system behind and send not just signals, but ourselves across the gulf to other stars? The solar system is our island, our sheltered harbor. The sun, immense and inexhaustible, binds planets, comets, and asteroids with the invisible leash of gravity. Like children orbiting their parent, the worlds remain tethered in cosmic dance. To escape this domain is not simply to move far enough away, but to break free from the sun's gravity well, to climb over an invisible wall of energy. It is as though the solar system were a valley surrounded by mountains of impossible height. To reach the other side, we must either climb or discover a new kind of path through. Imagine Earth as a shoreline and the interstellar void as a vast ocean. Reaching another star is like attempting to cross this ocean not in hours or days, but in lifetimes. The nearest shore, Proxima Centauri, is more than 4 light years away. Light itself, the fastest traveler known, takes over 4 years to bridge that gap. Our rockets, magnificent as they may be, are slow rowboats compared to the speed of light. They carried us to the moon in days, to the outer planets in years, but to the stars? At their current speeds, the journey would last tens of thousands of years, longer than recorded human history itself. The first lessons of interstellar travel came in 1977, when 2 spacecraft, Voyager 1 and Voyager 2, were launched. Their primary task was modest by cosmic standards: fly by Jupiter, Saturn, Uranus, and Neptune, collecting data and photographs. Yet, like wanderers who refused to return home, they continued onward. Decades later, both Voyagers are still traveling. Voyager 1, in fact, has already crossed into interstellar space, carrying with it the famous Golden Record, a time capsule of Earth's sounds, music, and greetings. Humanity's first hello to the galaxy drifts silently through the void, destined to outlast our civilizations, perhaps even our species. But here lies the sobering reality. Though Voyager travels at over 60,000 kilometers per hour, it will not reach another star system for tens of thousands of years. And yet, the very fact that we have already placed objects beyond the sun's protective bubble is astonishing. It proves that leaving the solar system is not fantasy, but a matter of scale and patience. If a small, car-sized probe can reach the interstellar medium, what about something greater, more ambitious? Here we collide with human limits. A machine can drift through darkness for millennia. A person cannot. The human body is a fragile ecosystem, dependent on warmth, food, air, and gravity. Beyond Earth, every step demands that we carry a miniature planet with us, a closed world capable of sustaining breath and blood, shielding fragile DNA from cosmic rays. A true starship is not a rocket, it is an ark, a floating biosphere where generations may live and die before the destination is reached. This raises profound questions. Are we willing to create such arks? Are we willing to launch expeditions knowing the pioneers will never arrive, that only their descendants will one day see another sunrise? Physics itself seems to conspire against us. To accelerate even a small spacecraft to 1/10 the speed of light, 0.1 c, would require more energy than all of humanity consumes in years. Our chemical rockets, brilliant fire lances that took us to the moon are utterly insufficient. To reach the stars, we need new engines, new fuels, new dreams forged in laboratories. Nuclear fusion, the same reaction that powers the sun, could in theory drive ships forward with immense thrust. Antimatter, rare and volatile, promises even greater energy densities. Though our ability to create and store it is negligible. Some whisper of warp drives, bending space-time itself, theoretical constructs that teeter between physics and imagination. Among the boldest modern ideas is Breakthrough Starshot, a project to send fleets of tiny, gram-scale probes to Alpha Centauri. Each would be attached to a wafer-thin light sail, propelled not by onboard fuel, but by enormous Earth-based lasers. Imagine a ship with no engine, no propellant, just a shimmering sail pushed by beams of light across the vacuum. Such probes could, in theory, travel at a fifth of light speed, reaching another star in mere decades. Of course, these are not ships for humans, but scouts, mechanical fireflies sent to explore the cosmic night. Meanwhile, visions of fusion-powered starships persist. One famous concept, Project Daedalus, designed in the 1970s, proposed a massive craft fueled by helium, 3 mined from gas giants, capable of reaching nearby stars within centuries. In more recent times, theoretical designs like antimatter-catalyzed fusion or inertial confinement drives expand the blueprints of what could be. And then there are the dreamers who contemplate bending reality itself. General relativity allows, in equations at least, the possibility of warp bubbles, where space in front of a ship contracts while it expands behind. The ship itself would ride this bubble, never breaking light speed, but arriving faster than light could by traversing normal space. Such concepts demand exotic matter and negative energy, things we have never observed nor manufactured. But who can say what future centuries might hold? Many once dismissed heavier-than-air flight as impossible. The boundary between fantasy and physics is drawn not by imagination, but by experiment. Yet before leaping across interstellar gulfs, humanity must first learn to thrive within its home system. We have barely set foot on the moon, barely sent robotic emissaries to Mars. To survive among the stars, we must master survival on Mars, on Europa, on Titan. We must learn to build closed habitats that recycle air and water, shield bodies from radiation, and generate power in places where sunlight is weak and fuel is scarce. These are not distant problems. They're the stepping stones of this century. Interstellar travel begins with a colony dome on Mars, a fusion reactor on an asteroid, a city orbiting Saturn. Some ask, is this even necessary? Could it be that we will never leave, that humanity will live and die beneath the sun's light? Perhaps. The distances are immense, the cost staggering. But to accept this would be to deny something essential in our nature. For as long as there have been humans, there have been wanderers. We crossed deserts, sailed oceans, climbed mountains not because it was easy, but because the horizon called. Each new frontier once seemed infinite, each barrier insurmountable, until it was crossed. To leave the solar system is not the dream of decades. It is the mission of millennia. It will demand not only physics, but philosophy, not only engines, but endurance. And yet, to imagine a future where some descendant of ours looks up at the night sky from a world orbiting another sun and points back toward a tiny, distant speck, the sun, as their home star. That image alone can fuel centuries of effort. To truly grasp what it means to leave the solar system, one must appreciate the scale of emptiness that awaits beyond its edge. Within our system, even the most distant planets are bound together by the faint warmth of the sun. Beyond, there is nothing but thin clouds of interstellar gas, scattered dust, and the silent pull of neighboring stars. For every grain of matter there are cubic kilometers of void. It is an environment not merely alien to human senses, but indifferent to them, a place where no sunlight warms and no air carries sound. To survive there, a ship must carry its own light, its own warmth, its own voice. The first great trial is energy. Everything about spaceflight reduces to energy. The energy to accelerate, to decelerate, to shield, to sustain. Our rockets today are magnificent bursts of chemistry, but they're the equivalent of campfires beside a star. To reach even a fraction of light speed, humanity must master energy on scales that dwarf entire nations. This is why physicists dream of fusion. The very reaction that powers the sun, fusion promises not just endurance, but efficiency. 1 gram of fuel yielding as much as tons of chemical propellant. The challenge is that the sun holds its plasma together with the crushing weight of its own gravity, something Earth cannot replicate. Our laboratories struggle to sustain controlled fusion even for seconds. And yet, the dream persists, for within fusion lies the bridge between rockets and starships. But propulsion is not the only frontier. Navigation across interstellar space is itself a problem of staggering subtlety. A starship must aim with exquisite precision, because a tiny error at launch could translate into millions of kilometers of drift after decades of flight. Even today, our best probes rely on course corrections along the way, using planetary flybys as slingshots. Beyond the solar system, there will be no friendly planets to lean on, no convenient sources of gravitational leverage. Instead, ships will steer by the light of distant stars, the faint pulse of quasars, or perhaps signals beamed from Earth. Imagine a vessel hurtling at 1/10 the speed of light, course corrections measured in fractions of a degree, every decision irreversible. Interstellar navigation is more like archery than sailing. 1 arrow loosed into the dark with no chance to retrieve it. Radiation is another invisible enemy. Within the solar system, we are protected by magnetic fields and atmospheres. Beyond them, a constant rain of high-energy particles, cosmic rays accelerated by ancient supernovae, bombards everything. These particles can pass through metal, damage electronics, mutate DNA. Shielding against them is not trivial. Thick walls protect, but mass slows a ship. Some concepts imagine magnetic fields generated by superconducting coils, wrapping a vessel in an artificial magnetosphere. Others propose using water tanks or fuel itself as shielding. But any solution must balance safety with speed. A starship cannot be both fortress and arrow unless we invent new materials, new physics. Then there is the human factor. Even if propulsion, energy, and shielding are solved, people must live within the walls of a ship for lifetimes. Psychology becomes as critical as physics. Imagine a crew born aboard, never seeing Earth, never breathing open air, their universe reduced to corridors and artificial gardens. They would not be explorers in a heroic sense, but caretakers of a moving habitat, entrusted with a mission they did not choose but inherited. Anthropologists and ethicists already debate what kind of society could endure such conditions. Would it be hierarchical, disciplined and rigid, or flexible, adaptive and diverse? Could democracy function aboard a ship where survival demands absolute cooperation? These questions blur into philosophy. Interstellar travel is not only a technical challenge, but a cultural one. For a voyage measured in centuries, the ship itself becomes civilization. Generations would rise and fall between the stars, their myths, languages, and rituals evolving in isolation. By the time they reached another world, would they even consider themselves human in the earthly sense? Or would they be something new, children of the void, shaped not by a planet, but by a starship's artificial rhythms? Some have suggested sidestepping these dilemmas entirely by removing the fragile body from the equation. Could we send only our minds, our intelligences encoded in machines? Digital probes carrying human consciousness, uploaded into silicon, would not tire, hunger, or age. They could endure centuries with patience no biological crew could match. Whether such a transfer of self is truly us is a debate as old as philosophy itself. But in practical terms, it may offer an efficient path to the stars. The interstellar travelers of the future may not be flesh and blood, but thoughts carried on light sails. Another possibility is cryonics, freezing crews into suspended animation for the duration of the voyage. Nature provides examples in hibernating animals, whose metabolic rates drop nearly to nothing during winter. If humans could be safely induced into such a state, a journey of centuries might pass in a single dreamless sleep. The ship would then be less a generation arc and more a flying cradle, bearing its passengers intact to another system. But hibernation remains speculative. Even if achievable, its psychological consequences, awakening in a new world, leaving behind all one has known, would be profound. Let's not forget the obstacles awaiting even if we arrive. Stars are not empty havens. Their planets may be barren, toxic, or storm-swept. The habitable zone, the narrow band where liquid water can exist, is precarious. Even Earth itself has not always been kind to life. To settle another system is not simply to land, but to terraform, to engineer ecosystems from scratch, to bend entire worlds toward our needs. In doing so, we would cease to be mere passengers in the universe and become its gardeners. Such an act would echo across philosophy and ethics. Do we have the right to alter other worlds? Or is survival justification enough? And yet, despite every difficulty, the allure is irresistible. The stars are silent, but they call to us. The human story is one of leaving safe harbors. Once we feared the forests, yet we stepped into them. Once we feared the seas, yet we sailed them. Now we fear the void, but someday we will cross it. The solar system is vast but finite. The galaxy beyond is infinite in comparison, a tapestry of billions of stars, each with planets, each with mysteries. To remain forever bound to one star is to live in a room while the door stands open. Technology may alter the form of our departure, but not the desire. Perhaps the first true interstellar travelers will be machines, scouts that send images home. Perhaps the next will be arcs of generations. Perhaps one day warp bubbles will make distances trivial. Each possibility extends from the same seed, the refusal to accept that horizons are final. To wonder what lies beyond is the most human question of all, and in that wonder lies our destiny. If one wishes to imagine humanity's path beyond the solar system, it is helpful to think not of leaps, but of steps. Great voyages are not sudden departures, but gradual rehearsals, each stage preparing for the next. Just as the age of exploration on Earth required ports, cartography, and generations of mariners before ships dared to cross oceans, so too will our interstellar era require a scaffolding of achievements within the solar system itself. The first stage is already underway: robotic scouts. Every probe we launch, Voyagers, Pioneers, New Horizons, is a rehearsal teaching us how to build machines that last decades in a vacuum, that operate at extreme distances where sunlight dwindles to a pale lantern. These scouts pave the way by exposing the unknown, how instruments degrade, how power can be generated without solar panels, how to maintain communication across billions of kilometers. Before humans travel, machines must blaze the trail. The next stage is permanent presence beyond Earth. A base on the Moon, a city on Mars, mining stations on asteroids. These are not mere symbols of ambition, but training grounds. They teach us how to recycle resources, how to maintain closed habitats, how to govern communities separated by distance and delay. Living on Mars, for instance, means surviving in a place where outside air cannot be breathed, where dust storms may last for months, where radiation levels are dozens of times higher than on Earth. To thrive, there is to learn lessons essential for interstellar travel. A Martian settlement is, in many ways, a miniature starship anchored to a planet. In the longer term, humanity will scatter throughout the solar system, turning it into a vast archipelago of outposts. Imagine orbital cities around Jupiter, suspended in protective radiation shields, floating colonies in the upper atmospheres of Venus, where temperatures and pressures are more Earth-like, research stations carved into the ice of Europa or Enceladus, where subsurface oceans may harbor alien microbes. Each of these settlements is a stepping stone, a rehearsal for adapting to environments unlike Earth. With every new habitat, we expand not only our reach, but our resilience. Yet expansion alone will not free us from the sun. To truly leave, we need propulsion systems far beyond our present capacity. Here the timelines branch into possibilities. In the near term, the next century or two, interstellar missions will likely be robotic. Laser sail probes may dart toward Alpha Centauri, sending back images of alien suns and planets. These will not carry humans, but they will carry humanity's curiosity. Each success will build momentum, proving that stars are not unreachable, but approachable with enough ingenuity. By the medium term, perhaps several centuries hence, fusion power vessels might become feasible. By then, humanity may have tamed the fusion reaction for power on Earth and in space. A starship driven by fusion could accelerate to speeds allowing journeys to nearby stars within hundreds, not tens of thousands, of years. Such voyages would still exceed human lifespans, demanding either generational arcs or suspended animation. But they would be real voyages, not eternal drifts. Humanity would become, for the first time, interstellar in presence, if not yet widespread. The far future, stretching thousands or tens of thousands of years ahead, may see technologies we can only speculate about today. Antimatter engines capable of near-light speed travel, perhaps even manipulation of space-time itself, allowing ships to leap across the cosmos. If such physics proves possible, the galaxy may one day be traversed as easily as seas on Earth. If not, then patience will be our companion. Slower, generational voyages, spreading across light years and centuries of determination. It is important to note that leaving the solar system does not necessarily mean abandoning it. Our descendants may still maintain civilizations around Earth, Mars, the moons of Saturn, while others voyage outward. The solar system will remain the cradle, even as children depart. In this sense, interstellar expansion is not escape, but growth. Like seeds carried by the wind, humanity will spread, but the tree remains. One crucial factor in all of this is communication. Even if ships depart, they will not be cut off. Beams of light, radio pulses, perhaps quantum channels will link them back to Earth. A starship 10 light years away may still send news home, though always with a delay. This delay itself will reshape human culture. Imagine conversations where replies arrive decades later. The sense of simultaneity that defines human society may fragment, giving way to a civilization spread not just in space but in time. A person on Earth may never live to see the reply from a message they send, but their descendants will. The dialogue between stars will be measured in generations. Another vital stepping stone may come not from humans, but from machines. Artificial intelligence, capable of self-repair and adaptation, may become the true pioneers. Unlike humans, machines need no oxygen, no gravity, no warmth. They can endure isolation without despair. If humanity succeeds in creating machines that not only think but imagine, then our first true interstellar emissaries may be not our bodies, but our minds reflected in silicon and photons. They may scout, prepare, and perhaps even build havens before humans arrive. The line between human and machine may blur, as biological and digital intertwine. In some scenarios, the first humans to walk on alien worlds may be hybrids, part flesh, part machine, carrying Earth's legacy in forms unrecognizable to us today. Consider also the role of necessity. Exploration has always been driven not only by curiosity, but by survival. Earth is resilient, but not eternal. Asteroids, supervolcanoes, climate shifts, and the eventual aging of the sun all pose threats across varying timescales. To remain bound to one planet, one star, is to accept vulnerability. Interstellar travel, then, is not only ambition but insurance. To spread across multiple systems is to safeguard the species, to place copies of humanity in many libraries so that no single fire can erase them all. In the long view, the departure from the solar system may be less a dramatic launch than a gradual migration. Ships may leave not once, but continuously, generation after generation, forming a stream of travelers flowing outward. Some may reach stars, some may fail, some may wander eternally between. Over millennia, the galaxy may fill with drifting descendants of Earth, each carrying variations of culture, language, and identity. They will not be a single humanity, but many threads of one origin woven into different tapestries. And yet, for all the grandeur of imagining, it is worth remembering the paradox. The journey begins here on a small blue planet orbiting a modest star. To dream of stars, we must first take care of this world, for it is the only platform from which departure is possible. A species that cannot preserve its own cradle cannot hope to build ships for eternity. In this sense, leaving the solar system begins not with rockets, but with responsibility to Earth, to ourselves, to the generations that will inherit both. The story of interstellar travel, then, is not merely about propulsion or physics. It is about patience, stewardship, and imagination stretched across centuries. It is about defining humanity not by where it is, but by where it dares to go. And when the day comes that a ship, bearing the legacy of Earth, crosses the darkness beyond the sun's dominion, it will not be just a triumph of engineering. It will be the continuation of a story as old as firelight and as vast as the stars. If interstellar travel is a question, propulsion is its grammar, the very structure by which answers must be written. Every vision of leaving the solar system is shaped by how one imagines motion across the abyss. Without a new language of engines, the stars remain ink blots beyond the page. Thus, the dreams of propulsion are not idle fantasies, but sketches of possibility, each a fragment of humanity's dialogue with physics. Consider first the solar sail. It seems almost like magic. a ship without fuel, pushed by nothing but light. Yet light has momentum, and though its push is faint, across years it accumulates. Imagine a sail the size of a continent, thinner than paper, stretched across space like a silver leaf. Photons, ceaseless and tireless, strike it and transfer momentum, nudging the ship forward. At first, the motion is imperceptible, adrift. But after months, years, decades, the vessel gathers speed, coasting ever faster, limited only by the size of its sail and the patience of its crew. Even more dramatic is the idea of a laser sail, in which powerful beams from Earth or orbiting stations accelerate a small craft to extraordinary velocities. The ship becomes a kite carried not by the wind, but by coherent light. Such a sail could drive gram-sized probes to a fifth of light speed, a feat unimaginable with chemical engines. While human-scale versions would demand unimaginable power, the principle remains one of the most elegant. Travel without carrying fuel, leaning instead on the most abundant traveler of all, light itself. Fusion propulsion, by contrast, is a hymn to fire. The sun burns by fusing hydrogen into helium, releasing torrents of energy. To harness this reaction aboard a starship is to carry a star in miniature. One proposed design, Project Daedalus, envisioned a massive vessel driven by pellets of deuterium and helium, 3 ignited by electron beams. Each pulse would detonate like a controlled nova, blasting plasma from the rear, hurling the ship forward. The calculations were audacious. Speeds of 1/10 the speed of light, voyages to nearby stars and centuries. The ship would be enormous, kilometers in length, but feasible in principle. It represented a bridge between the possible and the aspirational, a machine not of fantasy, but of future engineering. Then there are antimatter drives, the ultimate alchemy. When matter meets antimatter, they annihilate completely, converting mass into pure energy. No chemical or nuclear reaction comes close. A single gram of antimatter colliding with matter yields the energy of tens of thousands of tons of TNT. Harnessing this annihilation as thrust would give ships unprecedented power. The barrier is production. Our laboratories can create only nanograms of antimatter at immense cost. Containment is another trial, for antimatter annihilates on contact with ordinary matter, demanding traps of magnetic fields and near-perfect isolation. Yet if one imagines a civilization that can manufacture and store antimatter safely, its ships could traverse light years with an efficiency bordering on myth. Beyond engines that burn lies propulsion by geometry itself. The concept of a warp drive, born from Einstein's equations, suggests bending space so that a vessel does not move through it, but carries its own pocket of reality. Space contracts ahead, expands behind, and the bubble rides the distortion faster than light could traverse ordinary space. The ship itself never breaks relativity's laws, for within the bubble it remains stationary. But the universe outside is rewritten. Such a drive requires exotic matter with negative energy density, something never observed. Critics argue it may forever remain theoretical, and yet the mere presence of the idea in physics journals proves its seriousness. Not a fairy tale, but a hypothesis awaiting the judgment of discovery. Another path, quieter yet profound, is the idea of interstellar ramjets. First proposed by physicist Robert Bussard, the ramjet would scoop hydrogen from interstellar space, compress it, and ignite fusion to propel itself. In principle, such a ship would never run out of fuel, feeding continuously on the sparse but omnipresent atoms between the stars. The challenge lies in the density of that gas, far too thin for today's concepts of collection. But in imagination, the ramjet is the perfect voyager, a vessel that feeds on the very sea it sails. Even wilder are concepts of black hole drives. Hawking radiation, the faint emission predicted from evaporating black holes, could in theory be harnessed as thrust. A starship could carry a microscopic black hole, feeding it matter and directing its radiation rearward. This is not merely difficult, it is staggering in complexity. And yet, physics does not forbid it. The notion that humanity might one day harness the hunger of singularities for motion is both terrifying and exhilarating. These propulsion visions illustrate a deeper truth. Interstellar travel is not limited by imagination, but by engineering. Physics allows many possibilities. Technology decides which are real. It may be centuries before fusion, millennia before warp. But each idea widens the corridor of possibility, transforming never into someday. What unites them all is the problem of scale. To leave the solar system, we must think not in terms of missions, but civilizations. A fusion starship is not built in a workshop, but by an entire planetary economy devoted to the task. Antimatter factories would span moons. Warp experiments would reshape our concept of physics. The construction of such ships is itself a civilization-defining act, like the building of pyramids or cathedrals, but magnified across planets. Yet propulsion alone does not make a voyage. It must be paired with endurance. A ship crossing centuries cannot be brittle. Its systems must repair themselves, adapt, perhaps even evolve. One path is biotechnology, embedding living systems into the ship, making it a biome as much as a machine. Another is artificial intelligence, a vessel that thinks, learns, and maintains itself long after its makers are dust. The starship of the future may be less a machine we ride than a companion we trust, a partner in survival, a second species born of Earth's ingenuity. And still, propulsion concepts force us to reflect not only on physics, but on ambition. For in each vision lies a question. How far are we willing to go? A sail ship may carry probes, but not colonies. A fusion arc may take centuries, demanding generations to endure. A warp bubble may collapse physics as we know it. Which path we choose depends not only on science, but on what kind of civilization we become. Are we patient, willing to send missions that outlast empires? Are we bold, willing to gamble entire economies on a starship? Are we dreamers, willing to bend reality in search of freedom? The stars wait indifferent, but our engines, yet unborn, will one day answer. When we speak of leaving the solar system, we usually imagine engines, sails, and power. But behind the physics is something subtler. What does it mean for a civilization to step beyond its parent star? The question is not only one of technology, but of identity. For to scatter across the stars is to change, to become something other than what we were. And perhaps that transformation is the true journey. Culture has always been shaped by geography. Deserts fostered nomads, rivers birthed cities, oceans taught sailing. The solar system is geography on the grandest scale. A colony on Mars will not think as Earth does. A city under the ice of Europa will not dream the same dreams as one orbiting in free space. Gravity, day length, sky color, even the constellations overhead will craft new myths, new philosophies. To leave the solar system is to embrace not just distance, but divergence. Consider the problem of time. On Earth, civilizations rose and fell within centuries. Empires grew, flourished, and collapsed in less time than a voyage to Alpha Centauri might take. What kind of society can endure knowing its journey is longer than any nation has lasted? Such a society must invent new concepts of purpose. A generational starship cannot be driven only by curiosity. It must be anchored by meaning that survives across ages. Religion, philosophy, or shared myth may become the backbone, giving each generation a reason to continue the work of ancestors they never met, for descendants they will never see. Communication, too, reshapes culture. A message from Earth to a starship 4 light years away takes 4 years to arrive. The reply takes 4 more. Dialogue becomes epistolary across decades. News becomes history before it arrives. Each colony, each ship will grow culturally independent by necessity. Earth may remain the origin, but not the center. The human civilization of the future will not be one civilization, but a federation of timelines, each separated by light itself. And with separation comes evolution. Not biological evolution alone, though that too will occur as humans adapt to new gravities and environments, but cultural evolution. Languages will drift. Customs will diverge. After 1,000 years, the descendants of one starship may find Earth's speech foreign, Earth's rituals strange. They will still trace their origin to one blue planet, but identity will be fractured into many threads. The word human may become an umbrella, not a singularity. Philosophers already ponder this. At what point does a splinter civilization cease to be us? If a colony genetically engineers itself to thrive in low gravity, are its people still human? If a ship's inhabitants merge with artificial intelligence until they are partly digital, are they still human? Perhaps the answer is not yes or no, but both. Humanity will not remain one shape. To spread is to diversify, to become plural. And that plurality may be the strength that ensures survival. The ethics of such expansion are equally profound. If a starship arrives at a planet with life, microbial, primitive, or even complex, what then? Do we settle, terraform, transform? Or do we hold back, respecting alien ecosystems even at the cost of our own survival? Interstellar travel forces us to confront the possibility that we are not alone, that the universe is not empty but inhabited, however sparsely. To colonize recklessly is to risk becoming conquerors. To refrain may mean extinction. In this tension lies the deepest moral dilemma of the stars. Another cultural consequence lies in art. Human creativity has always responded to environment. Cave walls bore paintings of animals. Ships carried sea songs. Telescopes inspired symphonies. A civilization living between stars will birth art unlike any seen before. Imagine poetry written in the rhythm of long voyages, paintings that use the blackness of vacuum as canvas, music composed to echo within domes where silence reigns outside. The stars will not only reshape our bodies and societies, but our imaginations. Then there is the question of memory. When generations live and die aboard a vessel, the past becomes fragile. How do they remember Earth? Will they carry archives, libraries, museums aboard? Or will memory fade, replaced by myths that only vaguely recall a green-blue world? It is possible that, in time, Earth itself will become legend, a paradise once lost, a garden from which ancestors departed. To leave the solar system is to risk forgetting it. Only careful stewardship of memory, perhaps by artificial intelligences or digital archives, can preserve the truth across light years. In the very long term, as civilizations scatter across dozens, then hundreds of systems, unity may dissolve entirely. Each group may adapt so fully to its star and planets that cultural bridges collapse. Contact may still exist, but it will be like correspondence between nations today, cooperative at times, hostile at others, occasionally indifferent. The galaxy may become not a single empire, but a quilt of diverse societies, each tracing roots to Earth yet living lives so alien to one another they barely recognize kinship. This is not a failure, but the natural outcome of distance and diversity. Yet one thread may hold them together: the knowledge of origin. However far we travel, the story begins on Earth. That common ancestry may serve as the mythic bond, the way seafaring cultures recall the island from which they first set sail. Even if stars divide us, memory of a small planet by a yellow sun may remain the anchor of identity, the shared myth uniting countless descendants. And perhaps this is the greatest cultural transformation: humanity ceasing to be planetary, becoming cosmic. Today, we define ourselves by nations, by languages, by borders drawn on maps. Tomorrow, we may define ourselves by stars, by voyages, by the distances crossed. A person may say not, "I am from France," or "I am from China," but "I am from the Tau Ceti colony," or "my ancestors came on the third ship from Seoul." In this way, interstellar travel reshapes not only our future, but our very sense of who we are. Leaving the solar system is not simply a technical achievement. It is the rebirth of humanity in many forms. It is the scattering of one species into a multitude of descendants. It is the greatest cultural experiment ever undertaken, written not on parchment or canvas, but on the fabric of space and time. Once humanity begins to scatter beyond its native system, time itself becomes the stage of transformation. Interstellar distances are not measured only in light years, but in generations, and with them comes the slow reshaping of what it means to be a civilization. The solar system is our seed, but the galaxy is the soil in which that seed may take root, branch, and eventually bloom into forms unrecognizable to us today. In the earliest centuries of expansion, the great challenge will not be survival, but continuity. Knowledge, more than technology, becomes the true cargo of any interstellar journey. A ship may carry tools, machines, seeds, and habitats, but if the memory of how to use them is lost, all else collapses. History offers caution. Countless terrestrial societies rose with libraries of wisdom, only to see that wisdom destroyed by fire, war, or neglect. An interstellar voyage multiplies this risk 1,000-fold. Imagine a ship en route for 2 centuries. If its archives degrade, if languages shift, if curiosity wanes, the descendants may arrive at another star no wiser than ancient nomads. To cross interstellar gulfs is to carry not only bodies, but the fragile thread of culture itself. One solution is redundancy. Archives may be etched in diamond, encoded in DNA, stored in digital systems with layers of error correction. Artificial intelligences may serve as living libraries, tasked with remembering not only facts, but the spirit of Earth's cultures. These guardians of memory would be companions, teachers, and storytellers, ensuring each generation aboard a ship retains connection to its origin. In this sense, the first true interstellar migrants may travel not with silence, but with an entire chorus of history whispering in their ears. But memory also raises the question of change. Should future voyagers remain loyal to Earth's traditions, or evolve their own? Too rigid a culture risks stagnation. Too fluid, and memory dissolves. Likely, a balance will emerge. Earth remembered as origin, but not as prison. Just as immigrants on Earth created new nations while retaining fragments of old homelands, so too will starfarers weave hybrid cultures, half Earth, half void. Over millennia, this weaving will create a tapestry of civilizations more diverse than any seen before. What then of interaction between these scattered societies? The slowness of light ensures that unity cannot be maintained. Empires spanning light years are fantasy. Messages delayed by decades make centralized authority impossible. Instead, relationships will be looser, networks of exchange rather than hierarchies of control. A colony 5 light years away may still correspond with Earth, but news will be ancient by the time it arrives. Trade may occur, not in perishable goods, but in ideas, blueprints, and art carried by messenger ships or beams of data. The galaxy of the future will not be an empire, but a constellation of cultures, bound less by power than by shared ancestry. Still, contact will matter. A single breakthrough discovered on one world may alter the fate of many. If one colony masters a new form of propulsion or develops a medicine that defeats disease, others may adopt it centuries later. Knowledge will ripple outward, unevenly, unpredictably. Civilizations will leapfrog one another, sometimes surpassing their cousins, sometimes falling behind. The galaxy will become a living laboratory, each branch of humanity experimenting with survival in different conditions, each influencing the others across gulfs of time. Of course, not all interactions will be peaceful. Competition may arise, fueled by scarcity or ideology. Even across light years, conflicts could flare, wars of information, sabotage of signals, perhaps even assaults with relativistic projectiles. A vessel traveling at a significant fraction of light speed could, in theory, devastate a world if aimed with intent. The ethics of interstellar defense, deterrence, and diplomacy will be among the gravest questions our descendants face. How do you negotiate when every message takes decades, when misunderstandings can span generations? The very concept of war may evolve into something unfamiliar, shaped by the distances of the stars. Yet conflict is not inevitable. Distance also breeds independence. Many starfarers may care little for disputes on Earth or other colonies, focused instead on their own survival. Over time, isolation may lead to a patchwork galaxy where each society evolves largely alone, occasionally intersecting with others, but rarely seeking domination. The cosmos may become less a battlefield than a mosaic, each piece glowing in its own corner of space. The most profound transformation, however, may not be political but existential. To become a galactic species is to live with new scales of time and space. Civilizations will measure their history not in centuries, but in millennia, not in miles, but in parsecs. The perspective this grants may shift philosophy itself. Questions of personal life may seem trivial beside journeys lasting 10,000 years. Religions may emerge that worship the voyage itself, seeing the ship as temple, the stars as divine waypoints. Others may find meaning in the act of scattering, interpreting expansion as destiny written into the cosmos. And always, beneath these transformations, lingers the possibility of encounter. If we spread across the galaxy, what of others? The Fermi paradox, the silence of the skies despite the probability of other life, haunts every dream of expansion. Perhaps we are first. Perhaps others are distant. Perhaps civilizations rise and fall before they meet. Whatever the truth, a humanity that leaves the solar system will eventually answer it. We may find the ruins of predecessors, or the signals of neighbors, or perhaps only eternal quiet. Each possibility reshapes what it means to exist. In the most distant future, as thousands of years roll into millions, humanity may cease to be recognizable at all. Our descendants may be entirely post-biological, existing as swarms of machines, or as minds embedded in artificial worlds. They may no longer travel in ships, but in patterns of energy, spreading like seeds of thought across the Milky Way. The galaxy itself may become their body, the stars their neurons, the interstellar medium their bloodstream. In such a vision, leaving the solar system is merely the first step toward a destiny where intelligence saturates the galaxy. And yet, even then, even after eons, the story will trace back to one small world around one ordinary star. For no matter how far we travel, no matter how strange we become, Earth will remain the beginning. Its fossils, its oceans, its songs will echo as the origin of a species that dared to climb into the dark. Leaving the solar system is not abandonment, but expansion, the blossoming of Earth's life into the galaxy. The solar system is not eternal. Our sun, brilliant and steadfast for billions of years, is a clock. In roughly 5 billion years, it will exhaust its hydrogen, swell into a red giant, and eventually collapse into a white dwarf, a smoldering ember of its former self. For life on Earth, the consequences are catastrophic. Oceans boiled away, atmosphere stripped, the planet itself scorched and remade. If humanity still exists then, it cannot remain. Long before the sun's final transformation, we must have already scattered, not just to nearby planets, but beyond the reach of its death throes. This realization reframes interstellar travel. It is not only about exploration, not only about curiosity, but about survival on cosmic timescales. To remain tethered to a single star is to accept extinction with its inevitable demise. The stars themselves are lifeboats, each one temporary. To endure, humanity, or whatever intelligence it evolves into, must learn to move from star to star like nomads migrating with the seasons, except the seasons last millions or billions of years. In this far horizon, expansion becomes cyclical. Civilizations may rise around a star, flourish for millions of years, then depart as it fades, seeking younger suns. Whole cultures may be defined not by continents or planets, but by the age of the star they orbit. Imagine civilizations identifying themselves as children of red dwarfs or wanderers of collapsing giants. History will not be written in centuries, but in stellar epics. Some stars offer longer refuge than others. Red dwarfs, small and faint, burn their fuel slowly, living for trillions of years. A species that settles around such stars may endure for timescales dwarfing all of Earth's history. In contrast, massive blue stars blaze fiercely but briefly, their lives ending in supernovae after only millions of years. A civilization orbiting one would be forced to live urgently, knowing its home will explode in cosmic moments. These differences will shape not only survival strategies, but philosophies of time. But stars are not scattered evenly. To leap from one to another requires propulsion beyond anything we know today. Here, the speculative drives, fusion, antimatter, perhaps even warp, become not luxuries but necessities. The galaxy itself is a web of opportunities and risks, and civilizations must navigate it as carefully as sailors once read the winds. Even failure will shape destiny. Some colonies may perish with their stars, unable to move on. Others may thrive and spread. Over billions of years, natural selection applies not only to biology, but to civilizations themselves. Those that adapt to cosmic change endure. Those that do not vanish into silence. As time stretches, new challenges arise. Galaxies themselves evolve. Our Milky Way is on a collision course with Andromeda, set to merge in about 4 billion years. To any civilization alive then, The night sky will be transformed into a maelstrom of stars, new clusters forming, gravitational tides reshaping stellar orbits. For humanity's descendants, such an era offers both danger and opportunity. New stars and planets will be born, offering fresh worlds to settle. But gravitational chaos may fling systems into intergalactic exile, stranding colonies in lonely darkness between galaxies. Survival will mean resilience not just to stellar death, but to galactic upheaval. Beyond even this lies a more daunting truth. The universe itself evolves toward entropy. Stars one by one exhaust their fuel. Black holes consume matter, then slowly evaporate through Hawking radiation. In trillions upon trillions of years, galaxies dim, stars extinguish, and the cosmos drifts into what physicists call heat death, a state where no energy remains to drive life or motion. To contemplate this is to confront the ultimate challenge. Can intelligence survive when the universe itself declines? Some theories propose answers. Advanced civilizations might harvest energy directly from black holes, capturing the radiation of their slow evaporation. Others imagine engineering entire galaxies, reshaping the flow of stars to prolong habitable epochs. Some envision cosmic engineering so vast it defies comprehension. Structures the size of clusters, rearrangements of matter on scales beyond imagination. To endure against entropy, intelligence itself must become as vast as the universe. There is even speculation that escape may lie not within this universe, but beyond it. If physical laws permit the creation of new universes through quantum fluctuations, black hole singularities, or other means, then perhaps the ultimate fate of intelligence is to seed new realities. Each departing universe becomes not an end, but a womb. Humanity's descendants, evolved or transformed beyond recognition, may one day create offspring universes, carrying forward life and thought into fresh beginnings. In this vision, leaving the solar system is but the first step on a ladder that stretches to eternity. Yet amid these cosmic scales, there is humility. We are only at the beginning, a species barely capable of leaving its cradle. The technologies to move between stars remain dreams, the capacity to endure across millions of years untested. But the fact that we can even imagine such futures is itself extraordinary. In contemplating the death of stars and the heat death of the universe, we reveal the depth of our curiosity, a spark of intelligence daring to project itself across timescales far greater than its own fragile existence. The destiny of intelligence may be to outlast the stars, or perhaps intelligence is transient, a brief flame in the long darkness, destined to fade with its worlds. Both possibilities are awe-inspiring. If we endure, we become the architects of the cosmos, reshaping it to extend our story. If we perish, we remain a testament to the universe's ability to create awareness, however fleeting. In both, there is meaning. Leaving the solar system then is not merely about distance. It is about aligning ourselves with cosmic time. It is the first gesture in a dialogue with eternity. The starships of tomorrow, the colonies of future centuries, the galactic civilizations of distant ages, all are extensions of a single question asked tonight when a child looks at the stars. What lies beyond? When people imagine interstellar journeys, they often picture rockets and stars, but seldom the faces behind the windows. The engines may roar, the sails may gleam, the physics may guide the trajectory. Yet it is human hearts and minds that must endure the crossing. To leave the solar system is not only to depart from one star, but from everything familiar. The sky, the seasons, the gravity that shaped our bones, the very rhythm of sunrise and sunset. What, then, becomes of the individual human being in such a voyage? The first reality is isolation. On Earth, no matter how remote the village or how distant the island, the wider world always remains accessible. A traveler can write a letter, send a message, eventually return. But for those on a starship bound away from the sun, Earth becomes unreachable in every practical sense. Messages will still travel, carried on beams of light, but their delays will stretch into years. A child born aboard may never speak with grandparents left behind, except through fragments of recordings. A parent leaving Earth will know that their descendants will never set foot upon it. Every interstellar departure is also a farewell. And yet, within this farewell lies intimacy. On a ship, community is compressed, distilled. Every face becomes familiar, every story interwoven. Families will not merely raise children, but cultures. Each new generation aboard will be both kin and compatriots, bound by the shared fate of a journey none can abandon. Love, in such an environment, may take on a deeper gravity. Partnerships formed aboard a vessel will not be distracted by distant societies or alternative paths. They will be absolute, as necessary as air. Friendship, too, will carry a weight unimaginable on Earth, for each bond is part of the ship's survival. In such closeness, human emotion may become more intense, more deliberate. Still, hardship is inevitable. The monotony of space, corridors repeating, stars unchanging through viewports, may breed despair. Children will ask why they cannot run outside, why the sky is always the same. Artists aboard will struggle to paint landscapes they have never seen. Poets will describe sunsets they only know from archives. And yet, perhaps new art will rise. Art of the void, songs written in rhythm with the hum of engines, stories that celebrate the courage of leaving. Culture aboard a starship will be unlike any Earth has known, shaped not by landscapes, but by endurance. The human body itself will transform in subtle ways. Generations born in artificial gravity may develop new physiology. Perhaps bones will be lighter, adapted to rotation instead of planetary pull. Perhaps senses will sharpen, tuned to the enclosed environment. Biology will bend quietly, generation by generation, until one day the descendants aboard look back at Earth humans as slightly alien. Yet such differences will not erase kinship. They will enrich it as humanity unfolds into multiple forms. Psychologically, one of the greatest challenges will be purpose. On Earth, people live knowing their days are part of a cycle. Planting and harvest, birth and death, sunrise and sunset. Aboard a starship, the cycle is replaced by a line. Forward, always forward toward a destination that no one alive may see. How does one live with meaning in such a context? Perhaps by redefining purpose itself, no longer centered on arrival, but on continuity. To maintain the voyage becomes the act of faith, the shared mission that justifies every life. Parents may teach children not, one day you will arrive, but one day your children's children will arrive. In this way, purpose stretches beyond the self, anchoring individuals to a narrative longer than their own lifetimes. This creates a new kind of spirituality. For some, the ship itself may become sacred, the vessel not just transport, but temple. Its walls protect, its engines sustain, its systems nurture, as vital as any god. Rituals may grow around maintenance. The changing of filters, the checking of reactors, celebrated as communal rites. Others may direct reverence toward the stars themselves, each new point of light encountered seen as a holy waypoint. In this sense, interstellar travel is not merely physical, but metaphysical, reshaping humanity's relationship to meaning itself. Family life aboard a generational vessel also transforms. On Earth, children inherit land, wealth, culture. On a ship, they inherit responsibility. Every new generation must learn engineering, ecology, medicine, for without these, survival falters. Education is not optional, but essential. Each child is not only a person, but a future technician, caretaker, leader. In such a world, the boundary between family and society dissolves. To raise a child is to sustain the voyage itself. Parenthood becomes a civic duty, as much about preserving the ship as nurturing the soul. Romance, too, will be reshaped. Choices of partnership may be guided not only by affection, but by genetics, diversity, and the need to avoid inbreeding. Personal desire will intertwine with communal survival. Yet even within such constraints, love will find its path. Perhaps it will burn brighter because it is rarer, because every act of affection is also an act of defiance against the vast emptiness outside. Stories of interstellar lovers will become myths aboard, echoing through corridors long after their lifetimes. And then there is death. On Earth, the dead return to soil, oceans wind. On a ship, resources are too precious to release. Bodies may be recycled into nutrients, ash into soil, every atom reclaimed. To die aboard is not to vanish, but to feed the future. This may create new philosophies of death, where loss is softened by integration, the dead literally sustaining the living. Funerals may be less about departure and more about transformation, each individual continuing as part of the ship's closed cycle. For those who look outward, beyond the walls, the stars themselves will shape identity. Each new system passed, each nebula glimpsed, becomes part of communal memory. Children will grow not with maps of Earth's continents, but with charts of constellations along the voyage. They will learn to say, "Our ancestors left Sol, passed by Sirius. Now we travel toward Proxima." Geography becomes astrophysics, and home becomes a trajectory. All of this raises a profound question. What does it mean to be human when humanity leaves the context that shaped it? Is humanity defined by DNA, by culture, by origin, or by the ability to adapt, to carry meaning into new realms? The individuals aboard the first starships will test these definitions. They may discover that to be human is not to remain the same, but to change and endure while still remembering who we were. In this light, leaving the solar system is not merely about physics or engines. It is about the intimate, fragile lives of people, lovers, children, friends, dreamers, who carry the essence of humanity into the dark. The roar of propulsion may fade, but their laughter, their tears, their songs will echo across the void. They are the true explorers, the ones who turn the cold mechanics of interstellar travel into the warm continuation of a story begun under Earth's sky. A starship is more than metal and machinery. If it carries human life across the interstellar gulf, it must also carry a fragment of Earth itself. Every breath we take, every bite of food we consume, every drop of water we drink is part of a vast cycle that our planet perfected over billions of years. To leave the solar system is to replicate, in miniature, that astonishingly complex balance. A starship is not merely a vessel. It is an ecosystem, a moving planet compressed into steel and glass. Consider air. On Earth, oxygen is renewed by forests and oceans. The breath of animals becomes the fuel of plants. Carbon dioxide reborn as life spark. A starship must reproduce this exchange with precision, perhaps with algae tanks that bubble softly in the dark, turning waste into breath. Perhaps with hydroponic gardens where leaves rustle under artificial suns. Every lungful aboard is a partnership between humans and their carefully engineered green companions. To sustain life for generations, the recycling of air must be perfect, not as a luxury, but as a law. Water, too, is sacred. On Earth, it falls from the sky, trickles through rivers, gathers in oceans. On a ship, it must be captured, filtered, and endlessly reused. Every drop of sweat, every tear, every trace of condensation on a window becomes part of the closed cycle. Children born aboard may grow up with a reverence for water unknown to Earth societies. To them, every glass may carry molecules that once belonged to their ancestors. The poetry of continuity will be woven into every sip. Food requires an even more delicate balance. Fields and soils cannot accompany a starship in their natural form. Instead, life will be nurtured in vertical farms, nutrient solutions feeding roots suspended in air, artificial lights tuned to the rhythms of photosynthesis. Perhaps insects will hum in quiet hives, efficient converters of plants into protein. Perhaps vats of cultured meat will hum with bioengineered cells. The ship's cuisine may be simple, repetitive, but also deeply symbolic. To eat is not only to nourish, but to sustain the ecosystem itself. Each meal reminds the crew that survival is a cooperative act between species. Waste, which on Earth often disappears into forgotten corners, becomes central. Nothing can be discarded. Everything must return. Organic matter is composted into fertilizer. Metals are melted and reshaped, plastics broken down and reformed. Even human remains must rejoin the cycle, transformed into nutrients for plants, atoms continuing their journey in new forms. This is not only necessity, but philosophy. Aboard a starship, the concept of waste ceases to exist. Every molecule has purpose, but ecosystems are fragile. A single imbalance can cascade. If algae overproduce, oxygen may climb dangerously high. If a crop fails, hunger may ripple through the population. If disease spreads among plants or animals, the consequences echo across every system. For this reason, ecological monitoring will be constant, sensors tracking every parameter: humidity, pH, bacterial populations, with vigilance bordering on reverence. The crew becomes gardeners of existence, stewards of a living engine more vital than any reactor. This stewardship teaches humility. On Earth, ecosystems are vast and resilient, though we often take them for granted. On a ship, their fragility is visible, undeniable. A failing crop is not a news story, it is hunger. A leak in the water system is not an inconvenience, it is thirst. Such awareness may reshape human consciousness. Starfarers may develop a sense of ecological responsibility far deeper than anything we know today, born not of philosophy, but of survival. To harm the environment is to harm oneself. To nurture it is to live. Artificial ecosystems also invite creativity. A starship need not mimic Earth exactly. Perhaps its corridors are lined with gardens, where vines curl under lamps. Perhaps its water reservoirs double as tranquil lakes, where fish dart through recycled currents. Children might play among orchards that hum softly with pollinating drones. The ship becomes not only a machine of necessity, but a home shaped by imagination. Each decision, what plants to carry, what animals to include, defines the culture as much as the architecture. One ship may resemble a forest in a tube. Another, a crystalline city sustained by bioreactors. Each vessel is a new world designed with intent. The ecological lessons of such ships circle back to Earth itself. To build and sustain a closed ecosystem for centuries forces us to understand our planet's cycles more deeply than ever before. The air we breathe, the water we drink, the soil beneath our feet, all are revealed as parts of a machine infinitely larger and subtler than any starship. In trying to replicate it, we may finally learn to respect it. Interstellar travel, paradoxically, may make us better guardians of Earth, teaching us that survival is always ecological. Yet the greatest challenge may not be technical, but emotional. Life in a closed ecosystem can feel claustrophobic. No wild forests, no endless seas, no open skies. For some, this will inspire awe. The ship as a delicate jewel carrying life against impossible odds. For others, it may inspire longing, grief for the vastness of Earth's biosphere. To sustain morale, starfarers will need more than food and air. They will need beauty. Artificial skies projected on ceilings, gardens designed to echo Earth's landscapes, sounds of waves and birds carried in recordings. These recreations may never equal the original, but they may soften the ache of absence. And yet, over time, absence may become normal. For children born aboard, Earth will be a story, not a memory. The artificial garden will be their forest, the recycled water their ocean, the hum of ventilation their wind. They will love it not as a substitute, but as home. For them, the ecological balance will not be extraordinary, but natural, woven into identity. Their loyalty will not be to Earth's wilderness, but to the living system aboard their vessel. Humanity will learn to love what it creates, just as it once learned to love the lands it first settled. In this way, the ecological heart of a starship is not just technology, but philosophy. It embodies the truth that survival is interdependence, that no species thrives alone, that every breath is shared. To build such a system is to build a lesson. Life is fragile, precious, and communal. Perhaps that is the most valuable cargo any starship carries. Not people or machines, but wisdom distilled into practice. For when we finally leave the solar system, carrying forests in tubes, oceans in tanks, and skies in projections, we will not only be exporting humanity, we will be exporting Earth itself, its essence, its cycles, its beauty, transformed into miniature worlds sailing the dark. And in doing so, we may finally realize that Earth has always been a starship too, carrying us through space aboard its endless orbit of the sun. Every starship, no matter how graceful in concept or poetic in dream, begins as a political question. Who decides to build it? Who pays the price? Who is chosen to go? And who remains behind? To leave the solar system is not only a matter of physics, but of governance, the organization of human will and resources on scales no civilization has ever attempted. On Earth, history offers parallels. The pyramids, cathedrals, and space programs of the past demanded entire societies to mobilize around visions that span generations. But a starship surpasses all of these. It is not a monument, but a living civilization in motion. Its cost cannot be measured in currency alone, but in energy, time, and commitment. To construct such a vessel may require the output of entire planets. Orbital shipyards spanning thousands of kilometers, fusion reactors dedicated solely to fabricating materials, supply chains that stretch from Earth to asteroid mines and beyond. The decision to build is thus not an act of one government or one company, but of a united species, or at least a coalition strong enough to bear the burden. Economically, The investment is staggering. Even a modest interstellar probe, like the conceptual breakthrough Starshot, demands tens of billions of dollars. And that is only for gram-scale craft. A generational arc, kilometers long, self-sustaining for centuries, would dwarf every project in human history. How could such a cost be justified? Perhaps not in immediate return, but in survival itself. Just as insurance policies protect against catastrophe, so might starships be seen as humanity's ultimate insurance. Costly, but priceless if disaster threatens Earth. Yet survival is only one motive. Prestige may play a role, as it always has. Just as nations once raced to the moon, future powers may seek to lead the first exodus beyond the solar system. Economic incentives may also arise. The resources of the galaxy, metals, volatiles, energy sources, are vast. While interstellar mining may seem absurdly distant today, the lure of ownership, of being the first to stake claims among the stars, may one day become irresistible. A starship could be not only an ark, but a venture, its cost justified by the promise of entire new systems to develop. Still, politics shapes more than funding. It shapes governance. Who rules aboard a starship? Unlike a colony on Earth, a ship cannot tolerate chaos. Its ecosystem is fragile, its systems interdependent. Every decision matters. Every failure risks lives. Too rigid a hierarchy may suffocate creativity. Too loose a democracy may endanger stability. The balance must be precise. Perhaps governance will resemble a council of specialists. Engineers, doctors, ecologists, each representing the essential systems of the vessel. Or perhaps authority will rotate, ensuring no single group ossifies into power. Whatever the model, it must evolve with the voyage, adapting to new challenges while preserving unity. Law itself takes new forms in the void. On Earth, laws rest on land, borders, and states. Aboard a ship, none of these exist. Law is not about territory, but about harmony within a closed community. Justice must be swift, but also humane, for exile is impossible. Punishment cannot mean exclusion. It must mean reintegration. Rehabilitation becomes necessity. Crime aboard may decline, not from morality, but from the sheer impossibility of living without cooperation. Yet conflicts will arise, of passion, of ideology, of scarce resources, and systems must exist to address them without tearing apart the fragile fabric of society. Representation, too, is transformed. A starship may leave Earth with carefully chosen crews, trained and selected. But as generations pass, those aboard may resent decisions made centuries earlier. Why should the descendants obey rules written by ancestors who never knew them? The ship becomes not just a vessel, but a nation in its own right, with sovereignty to reshape its laws. Earth's influence will fade, not by rebellion, but by distance. In this way, every starship is not merely a colony, but the seed of a new civilization. Economically within the ship, scarcity defines value. Metals, plastics, nutrients, all are limited, all must be recycled. The economy may resemble a closed-loop system where currency is less important than rationing and exchange of duties. Or it may evolve into symbolic forms, where tokens of labor or trust act as measures of worth. Money as we know it may lose relevance. Value may be defined not by accumulation, but by contribution. The most honored profession may not be merchant or soldier, but gardener, engineer, teacher, those who sustain the continuity of the voyage. Technology reshapes economics further. If matter can be endlessly recycled, if energy is provided by fusion, then scarcity shifts from material to knowledge and skill. The economy of a starship may be one of expertise, a society where education is the greatest wealth, where memory itself is the most precious resource. In this sense, the political economy of interstellar travel may resemble a monastery as much as a marketplace, a community bound by shared survival, sustained by the preservation and application of knowledge. Externally, relations between Earth and starships pose new challenges. Who owns a ship? Is it property of its builders, or sovereign once it departs? If it discovers a habitable world, does it claim it for humanity as a whole, or for itself alone? These questions echo the debates of colonialism on Earth, but magnified across light years. Delayed communication ensures that enforcement is impossible. In practice, each ship will be independent, free to interpret its mission as it sees fit. Earth may send instructions, but centuries later, they will be little more than relics of intention. Autonomy will be the rule, not the exception. This autonomy introduces the possibility of divergence in political philosophy. One ship may adopt strict hierarchy, another egalitarian democracy, another technocracy ruled by engineers. Over centuries, these models may diverge as radically as Earth's nations once did, creating political diversity across the stars. Some may thrive, others may fail. The galaxy becomes a political laboratory, each starship a different experiment in governance. And what of conflict between ships? Unlike nations on Earth, separated by borders but able to clash, ships in space are separated by light years. War, in the traditional sense, is impractical. By the time a hostile ship arrives at its target, centuries may have passed and intentions may have changed. Yet competition could still exist for habitable worlds, for prestige, for ideological supremacy. Perhaps rivalries will be fought not with weapons, but with culture, with ideas transmitted across the light years. Each ship trying to influence the others through philosophy, art, or religion. A war of stories rather than swords. Ultimately, politics and economics in interstellar travel converge on a single truth. Cooperation is survival. A starship is the purest example of interdependence. Its economy cannot tolerate waste. Its politics cannot tolerate division. Its society cannot tolerate neglect. Every system, every role, every individual is part of a single organism. Perhaps, ironically, the stars will teach us what Earth often forgets, that civilization is strongest when it understands itself as a network of mutual reliance. The decision to leave the solar system will be humanity's greatest political act. It will demand unity at scales unprecedented, investment beyond measure, and governance capable of stretching across centuries. But in succeeding, it may also transform us. We may discover that politics, once rooted in territory, evolves into politics rooted in purpose. That economics, once driven by accumulation, evolves into economics of sustainability. And that humanity, once fractured by nations, finds unity not in conquest, but in the shared journey toward the stars. A starship crossing the interstellar void is not only an engineering project, but a theater of the mind. The distances are so immense, the journey so long, that survival depends not just on fuel and food, but on the inner worlds of its travelers. How does the human psyche endure centuries without familiar landscapes, without open skies, without the grounding presence of Earth? The answer lies in imagination, the power to transform confinement into creativity and monotony into meaning. Psychology in deep space will be unlike any faced before. On Earth, monotony can be broken by change, the turn of seasons, the bustle of cities, the presence of strangers. Aboard a ship, life is repetition. The same corridors, the same gardens, the same faces day after day. For some, this constancy may bring stability, a sense of comfort. For others, it may erode the spirit, breeding restlessness and despair. To prevent collapse, entire disciplines of mental health must evolve, focused not on treating illness after it appears, but on cultivating resilience before it begins. Art becomes vital in this context. On Earth, art often reflects environment. Landscapes painted, oceans sung, skies photographed. Aboard a ship, environment is static. Art will not echo the outside world, but create new ones. Painters may invent alien horizons they have never seen. Poets may write verses that describe worlds yet to be reached. Musicians may compose pieces that mimic the rhythms of engines or the hum of life support. Art in space is not a mirror, but a lamp, illuminating possibilities that reality withholds. Technology extends this creativity. Virtual reality may become the canvas of choice, allowing crew members to walk through forests, sail oceans, or soar over mountains simulated in exquisite detail. These worlds may be modeled on Earth or invented entirely anew. Landscapes of imagination where gravity bends strangely, skies shimmer with unfamiliar colors, or time flows differently. For starfarers, such experiences will not be mere entertainment, but therapy, offering relief from the confinement of steel walls. Yet virtuality also raises questions. If life inside simulations becomes richer than life aboard the vessel, will people prefer the unreal to the real? Will children born aboard view the physical ship as drab compared to the wonders of their virtual playgrounds? Perhaps balance will emerge, reality providing survival, virtuality providing wonder. Or perhaps future generations will fuse them, blurring the line between what is lived and what is imagined. Storytelling will also transform. On Earth, stories often unfold in days or years. On a ship, the narrative scale stretches to generations. A child may grow up hearing tales of Earth they will never see, told not as fact but as legend. Once, there was a blue planet with oceans so wide you could sail for months without seeing land. To young ears, such words may sound like myths of paradise. Over time, Earth itself may become less history than mythology, its reality blurred by centuries of retelling. New myths will also be born aboard. The ship itself may become a character, the guardian, the mother, the sacred vessel. Stories may arise about the first crew, about sacrifices made to keep systems alive, about near disasters averted. These tales, told and retold, will become the cultural foundation of generations. Just as ancient peoples told of floods, heroes, and creation, starfarers will tell of reactors, gardens, and departures. Myth-making will not vanish. It will shift, anchoring meaning in the voyage itself. Philosophy, too, will evolve. On Earth, much philosophy grapples with existence in a world of abundance and change. On a ship, the conditions are different: scarcity, confinement, permanence of mission. Questions will revolve around purpose. Is it better to live for a goal one will never see, or to find fulfillment in daily stewardship? Is existence aboard a vessel a limitation or a liberation? Perhaps entire schools of thought will emerge, teaching that meaning lies not in arrival, but in participation, not in destinations, but in continuity. Psychological resilience will depend on rituals. Humans anchor themselves in rhythm, daily, weekly, seasonal cycles. Aboard a ship, artificial cycles may replace natural ones. Lights dim to simulate night, brighten to simulate day. Communal festivals may be invented to mark milestones of the voyage, anniversaries of departure, alignments with distant stars, the first glimpse of a target system. Such rituals become anchors, keeping minds oriented in the vastness of time. Education will also take on new psychological weight. Every generation must be trained not only in survival skills, but in identity. Children must learn who they are, why they travel, what they represent. Without this, meaning evaporates and despair grows. Lessons will include history of Earth, not only as fact, but as heritage, astronomy, to connect the ship's journey to the cosmos, philosophy, to nurture purpose. In this way, education becomes the immune system of the mind, guarding against hopelessness with knowledge and belonging. And yet, creativity will not be only medicine. It will also be joy. Imagine music composed in microgravity, instruments designed to exploit the absence of weight. Imagine dance performed in rotating habitats, bodies moving in spirals impossible on Earth. Imagine theater staged with the ship's corridors as sets, plays written about the struggle between human and void. The arts will not merely preserve sanity. They will flourish, creating entirely new genres born of the interstellar condition. From such creativity may emerge identities no longer tied to Earth, but to the voyage. A child born aboard may say, "I am of the ship," with pride, not regret. Their art, their rituals, their philosophy will reflect this belonging. Over centuries, starfarers may see themselves not as exiles from Earth, but as pioneers of a new mode of being. Humans not bound to planets, but to stars themselves. Their creativity will be the declaration that they are not lost, but becoming. For ultimately, interstellar travel is not only about where we go, but how we imagine while we go. Without imagination, the void is emptiness. With imagination, it is a canvas. And in that canvas, humanity will paint not only the stars it sees, but the worlds it dreams. Every great journey of humanity has yielded not only expansion, but knowledge. Crossing oceans revealed new lands, but also new stars for navigation, new species, new philosophies. So too will crossing the interstellar sea. The act of leaving the solar system is not only survival or ambition. It is science on the grandest scale, a chance to ask questions impossible to answer from within the sun's gravitational cage. One frontier is the interstellar medium itself. For centuries, astronomers have peered outward, seeing only faint shadows of dust and gas between stars. But these clouds, though tenuous, shape the galaxy. They birth new suns, scatter light, carry the chemical seeds of life. To travel through them is to study them directly. Instruments aboard a starship could measure density, composition, magnetic fields, cosmic rays with a precision no Earth-based observatory can match. Each data point would illuminate how galaxies breathe, how matter cycles between stars, how life's ingredients are distributed across the cosmos. Another frontier is stellar physics. From Earth, we observe stars as distant points. Even the nearest are suns blurred by light years. To reach another system is to transform astronomy into geology, to walk up to a star and study in detail. Imagine orbiting Alpha Centauri and watching its corona flare, measuring its magnetic storms, mapping its sunspots with instruments hovering in situ. Entire disciplines of astrophysics would be reborn, moving from inference to direct observation. We would learn not only about those stars, but about our own sun by comparing it in context with its siblings. Planets beyond the solar system are another vast mystery. Thousands have been detected by telescopes, their existence revealed through faint wobbles and shadows. But detection is not presence. To land on an exoplanet, to walk its soil, to breathe or fail to breathe. It's air. That is knowledge no telescope can provide. Are alien worlds covered in oceans, or deserts of glass, or jungles of ammonia? Are their skies blue, red, or green? Do they carry magnetic shields, tectonic plates, climate stable enough for life? The first human footprints on an alien planet will be more than symbolic. They will be the first experiment in comparative planetology beyond our own system. And then there is the greatest scientific frontier of all, life. For centuries, we have asked whether Earth is unique. Biology on Earth is robust, but parochial, one data point in an otherwise silent galaxy. To study another biosphere, microbial or complex, primitive or advanced, would answer questions we can scarcely frame. Do all living systems rely on DNA-like molecules? Do they use carbon or silicon or something unimaginable? Does evolution always lead to complexity, or is Earth exceptional? If life is common, then we are participants in a vast cosmic community. If life is rare, then we are its sole guardians. Either answer changes our place in the universe. Interstellar travel also opens the door to testing the laws of physics in extreme conditions. At velocities approaching a significant fraction of light speed, relativity ceases to be abstract and becomes practical. Time dilation will not be theory, but experience. A ship traveling at 0.2 c may return to find centuries passed on Earth while only decades passed aboard. Such experiments extend Einstein's equations from mathematics into lived reality. They also allow tests of whether the speed of light is truly constant, whether space-time behaves as predicted under conditions never before achieved by human hands. Cosmic rays, magnetic fields, dark matter, all will reveal themselves differently beyond the sun's protective bubble. Even now, Voyager instruments are probing hints of cosmic mysteries, measuring differences in radiation and plasma. A true starship would turn those hints into clarity. It may even help answer the greatest puzzle of modern physics. What is dark matter, the unseen mass shaping galaxies? Perhaps instruments carried between stars, sensitive to subtle interactions, will detect its presence directly. Interstellar science is not only expansion outward, but inward, into the deepest structures of reality. And there is the possibility of surprises. Every time humanity has looked farther, it has been astonished. The first telescopes revealed moons around Jupiter, nebulae that were galaxies, expanding space itself. To step beyond the solar system is to open a new window, and there is no predicting what lies beyond. We may find phenomena we cannot explain, magnetic storms of unprecedented intensity, rogue planets wandering alone, filaments of plasma stretching across parsecs, or structures hinting at intelligence. Science thrives on the unexpected, and nothing is more likely to surprise than the unexplored. The act of departure itself generates new knowledge. To sustain a biosphere aboard a ship teaches ecology more deeply than centuries of Earth-based study. To engineer propulsion systems capable of fractional light speed expands energy physics into realms unimagined. To govern closed societies across generations teaches sociology in a way no terrestrial experiment can. In leaving, we do not only learn about the stars, we learn about ourselves. And perhaps the ultimate scientific frontier is perspective. Looking back at the solar system from light years away, humanity will see its cradle as a paled, not in poetry, but in lived experience. Earth will be a point of light among many, and we will measure it against the stars we reach. That act of comparison will change science forever. We will no longer ask, what is Earth? But what is Earth among worlds? The scientific value of leaving the solar system is thus immeasurable. It is the continuation of the same impulse that drove humans to climb mountains, sail oceans, build telescopes. Curiosity is not a luxury. It is the essence of being human. To step into interstellar space is to extend that curiosity to its greatest horizon. When humanity first gazes back at the solar system from beyond its borders, the view will be breathtaking, a sun reduced to a star among billions. Yet with that view comes responsibility. To step into interstellar space is not only a triumph of engineering, but an act heavy with consequence. Every decision we make as we scatter across the galaxy will echo through millennia, shaping not only our fate, but the destiny of life and intelligence itself. The first ethical question is survival itself. Some argue that leaving the solar system is unnecessary, that Earth can sustain us if we act wisely. Others counter that the sun's eventual death or unforeseen catastrophes make expansion essential. At the heart of this debate lies the tension between stewardship and escape. Do we owe our loyalty to Earth to preserving it no matter the cost? Or is our responsibility broader, to ensure life continues even if Earth fails? To leave does not mean abandoning, but it does mean shifting loyalty from a single planet to life itself. Then comes the question of representation. Who goes? A starship cannot carry everyone. Choices must be made: genetic diversity, skill sets, health, psychology. But how to select without injustice? If only the wealthy or powerful are chosen, the voyage becomes not humanity's step outward, but a continuation of inequality. If selection is random, survival may falter. The criteria will reflect values. Do we prioritize survival efficiency or fairness or cultural preservation? Each choice shapes not only who travels, but who humanity becomes. Ethics extends also to contact with other worlds. Suppose we find a planet rich with life, microbes beneath ice, forests breathing alien air. Do we colonize, transforming it for ourselves? Or do we preserve it, leaving its biosphere untouched? On Earth, we have often reshaped environments without hesitation, driving species extinct for our gain. Among the stars, the stakes multiply. To erase an alien biosphere, however primitive, is to silence an independent experiment of the universe. Do we have that right? Or do we owe reverence to life in all its forms? No matter how humble, even lifeless worlds pose dilemmas. Terraforming a barren planet into habitability may seem harmless, reshaping rock into a garden. But what if unseen microbial life slumbers there, waiting to awaken? By altering it, do we erase potential futures? Ethics will demand caution, humility, and perhaps a new code. Not planetary ownership, but planetary guardianship. The stars may force us to rethink what it means to possess a world. Another frontier of ethics lies in our own transformation. To survive long voyages, we may alter ourselves genetically, cybernetically, digitally. If we engineer children to thrive in low gravity or fuse minds with machines, are we still human? Do we owe loyalty to our unaltered form or to continuity of consciousness, however transformed? Perhaps multiple answers will emerge. Some starfarers will preserve humanity as it is. Others will embrace radical evolution. Ethical debates will then expand. Not, is this good for humanity, but is this good for which humanity? Interstellar governance itself demands ethics. On a ship, resources are finite. Who decides how to allocate them? Who decides who may have children? How many? When? These are not abstract questions, but matters of survival. Yet to reduce life to calculation risks cruelty. The challenge will be to balance compassion with necessity, freedom with sustainability. Entire ethical systems may be invented aboard ships, blending utilitarian calculations with human dignity. What emerges may not resemble any moral system on Earth, but it will be no less profound. And beyond all, there is the ethical question of legacy. We're the first species on Earth capable of leaving. If we succeed, we become the seed of intelligence across the galaxy. But what kind of seed will we be? Will we carry with us the scars of war, exploitation, and inequality, reproducing them among the stars? Or will we learn from history, choosing instead to build civilizations rooted in justice, cooperation, and respect? To leave the solar system is to export not only DNA, but values. The future of the galaxy may depend on what we choose to embody. This responsibility is immense because life may be rare. If we are the only intelligent beings, then we are the guardians of awareness itself. If we fail, consciousness in the universe may vanish. If we succeed, intelligence may bloom across countless stars. In that sense, every ethical choice we make carries cosmic weight. To harm one another, to waste resources, to exploit life. These are not only human failings, but potential galactic tragedies. To act with care, to nurture, to preserve. These are not only virtues, but cosmic obligations. Even communication across light years will carry ethical dilemmas. Suppose a colony receives a message from Earth demanding loyalty. Should they obey centuries later, when their society has evolved beyond recognition? Does Earth have the right to impose its will, or does distance grant freedom? Conversely, should a colony warn others of mistakes it made, even if the warning arrived generations too late? Ethics in the interstellar era will not be about immediacy, but about responsibility across time. Our descendants must act not only for themselves, but for those who will read their choices centuries later. The expansion itself raises a paradox. To survive, we must scatter, but scattering means division. Unity cannot be enforced across light years. Each colony will carry its own interpretation of ethics, its own values. Some may prioritize individuality, others collective survival. Some may cherish biodiversity, others reshape it freely. The galaxy may become a patchwork of moral codes, none universal, all reflections of different paths. Perhaps this diversity is itself ethical, a recognition that there is no single way to live, only many ways to endure. And yet, even in diversity, some principles may unify. Reverence for life, awareness of interdependence, responsibility to future generations. These may become the foundation of an interstellar ethic. They are lessons already visible aboard small spacecraft today, where every resource is precious and every decision matters. In the void, ethics is not philosophy alone, but survival. To care for the fragile is to endure. To neglect, it is to perish. Ultimately, leaving the solar system is not merely a technical act, but a moral one. It asks humanity to decide what it values most, what it carries outward, what it leaves behind. It forces us to confront our failures and choose whether to repeat them or transcend them. It challenges us to see ourselves not only as individuals or nations, but as a species standing at the threshold of cosmic responsibility. And when the first starship sails into the dark, carrying forests in miniature archives of memory and hearts full of hope, it will not only represent what humanity can do, it will represent what humanity has chosen to be. The image of humanity as a galactic civilization begins not with a single ship, but with countless departures. One vessel may head toward Alpha Centauri, another toward Tau Ceti, another toward Epsilon Eridani. Each sets out on its own trajectory, each carrying fragments of Earth, languages, traditions, technologies, dreams. At first, they're lonely embers, tiny fires cast into the dark. But over millennia, as more ships depart and more colonies form, those embers multiply. The galaxy begins to flicker with the lights of scattered communities, each a spark of intelligence sustained by human persistence. This scattering transforms history. No longer is humanity defined by one homeworld or even one star. Instead, it becomes a family of civilizations spread across thousands of light years. Some will remain small, self-contained outposts. Others will grow into planetary societies, developing cultures as rich and distinct as any that arose on Earth. Over time, the differences between them will deepen. New languages, new arts, even new biologies adapted to alien environments. Diversity will not be incidental. It will be destiny. Yet diversity does not mean isolation. Even across light years, communication remains possible. Though slow, signals can carry knowledge, stories, discoveries. A message sent from one system may take decades or centuries to arrive, but it will arrive, binding distant colonies in a web of delayed dialogue. Over time, this exchange becomes the nervous system of a galactic civilization. Slow compared to thought on Earth, but vast in reach. Each message is a gift passed across generations. A poem, a blueprint, a warning, a hope. The galaxy becomes a library written in light. Such a civilization cannot be centralized. There will be no empire of the Milky Way ruled from a single capital. The speed of light forbids it. Instead, governance will be distributed, local autonomy the norm. Each world decides its own fate, but shares in collective knowledge. The galactic civilization is less a hierarchy than an ecosystem, a forest of cultures, some in contact, some isolated, all rooted in the same ancient seed of Earth. Trade will exist, but in unusual forms. Perishable goods cannot cross light years. By the time they arrive, generations have passed. Instead, trade will focus on information, art, genetic material, advanced technologies. A new alloy discovered on one world may be replicated elsewhere once the method is transmitted. A novel gene to resist disease may be shared as digital code to be synthesized light years away. In this sense, the galactic economy will be one of ideas rather than objects, invention rather than material. Art, too, will weave the network. Imagine a song composed on a distant colony, transmitted across centuries, arriving at Earth long after the composer has turned to dust. Generations later, another artist replies, creating a dialogue of music stretched across time and space. The galaxy becomes not just a physical web, but a cultural symphony, each voice separated by distance, yet harmonizing across light. Such exchanges will not erase differences, but celebrate them, each culture contributing unique threads to the cosmic tapestry. Over the ages, some civilizations may rise to great heights of power and knowledge, while others decline. The galaxy's history will not be linear, but cyclical. Flourishing here, fading there, new colonies born, old ones forgotten. To future historians, mapping these cycles may resemble tracing constellations, each star a story, each gap a silence. The very fabric of galactic civilization will be woven of endurance and loss, brilliance and decay, continuity and transformation. Technological convergence may shape this history. If faster-than-light communication or travel is ever discovered, the structure of civilization would change dramatically. What was once a loose federation of isolated systems could become a coherent whole, with real-time dialogue binding stars together. But even without such breakthroughs, the slower web of light-speed communication is sufficient for identity. Civilizations may not be united politically, but they will be united by memory, by shared origin, by the recognition that they are all children of one small planet orbiting an unremarkable star. The presence of other intelligences, if they exist, complicates this vision. If humanity encounters alien civilizations, cooperation or conflict may shape the galactic future. Perhaps alliances will form, networks of species exchanging knowledge. Perhaps borders will be drawn, treaties signed, wars fought. Or perhaps the silence continues, leaving humanity to populate the galaxy alone, becoming not one among many, but the only torchbearer of consciousness. In that case, our expansion is not merely survival, but responsibility, to fill the galaxy with thought so that it is not silent forever. On cosmic timescales, even galaxies change. Stars are born and die, clusters drift, galaxies collide and merge. A galactic civilization must adapt not only to its own diversity, but to the evolution of its environment. Worlds will be lost to supernovae, others destabilized by gravitational shifts, still others terraformed anew. Survival will demand flexibility, migration, reinvention. But with each challenge overcome, intelligence grows stronger, more resilient, more enduring. Perhaps the ultimate expression of galactic civilization is synthesis. Imagine a network where information flows so freely that knowledge itself becomes shared, where discoveries made on one world are instantly integrated into the memory of another, where ideas outlive their creators by millennia, where the sum of intelligence grows steadily with time. The galaxy itself becomes a mind, each civilization a neuron, each message a synapse. Humanity, once fragmented into nations, then scattered into colonies, may one day reunite not through power, but through understanding, not through conquest, but through communication. And beyond the galaxy lies even greater possibility. Just as humans left continents for oceans, then planets for stars, so too may they leave galaxies for clusters. Over billions of years, intelligence may spill outward, crossing the voids between galaxies, seeding filaments of the cosmic web. The vision of galactic civilization becomes, in time, intergalactic. The scale of identity expands once again, until the Milky Way is only the first chapter of a far greater story. Yet through all these transformations, one truth persists: the seed remains Earth. No matter how diverse the future, no matter how alien the descendants, the beginning lies with a small blue world around an ordinary Sunday. The galaxy may one day be filled with voices, but all will trace their lineage back to the first humans who dare to leave their cradle. That continuity, fragile, improbable, miraculous, is the true foundation of galactic civilization. If humanity's story expands to fill the galaxy, the next question is inevitable. How far can intelligence go? Stars are temporary. Galaxies are temporary. Even the fabric of the cosmos is temporary. To imagine the long future is to confront the possibility that all things end. And yet, if life is tenacious enough to cross interstellar space, perhaps it will be bold enough to wrestle with eternity itself. The first challenge is the death of stars. Even red dwarfs, the most enduring, burn out after trillions of years. When they fade, the galaxy will grow dim. Civilizations that once thrived in stellar light must seek new sources of energy. Some possibilities lie in physics we already know. Black holes, for example, are not only destroyers but potential power plants. As matter falls into them, it releases immense energy. Advanced societies could harvest that radiation, building structures like Dyson spheres around black holes to catch the light of destruction. Others might exploit Hawking radiation, the faint evaporation that causes black holes to slowly vanish over unimaginable timescales. If such energy can be captured, intelligence could survive far beyond the lives of stars. Another possibility is stellar engineering. Stars are not eternal, but they can be manipulated. Theoretical megastructures, star lifting, could siphon material from suns, extending their lifetimes by slowing their burn. Fusion reactors built on astronomical scales could reignite cooling stars or combine them into new ones. A galactic civilization with mastery of energy may not passively await stellar death, but actively sculpt the sky, reshaping stars themselves to prolong habitability. Yet even with such feats, darkness grows. As billions of years roll on, galaxies merge, black holes consume matter, and dark energy pushes the cosmos into accelerated expansion. Eventually, galaxies drift so far apart that no light crosses the void between them. To civilizations of that future, the universe will appear smaller, lonelier, their galaxy the only island visible. Knowledge of the wider cosmos may survive only in archives, with no stars left to confirm it. The universe itself conspires against eternal connection. What then? Perhaps intelligence will compress itself, shrinking to endure with less. Miniaturized minds, digital entities, may survive on tiny trickles of energy, stretching thought across eons by slowing time itself. Moments of consciousness could be spaced by millennia of silence, conserving energy while waiting for another burst. In this scenario, intelligence does not vanish but hibernates, dreaming through eternity, flickering like embers in the cold. Some speculate that the laws of physics may offer escape routes. Wormholes, if they exist, could link distant regions of space-time, bypassing the isolation of cosmic expansion. Exotic matter might stabilize them, allowing civilizations to create shortcuts through the universe even as galaxies drift apart. Others imagine creating entirely new universes, bubble cosmos birth from quantum fluctuations or black hole singularities. If possible, this becomes the ultimate act of survival, seeding fresh universes where intelligence can begin anew. In this vision, the destiny of humanity's descendants is not merely to inhabit the cosmos, but to generate it, becoming midwives of reality itself. But even without such bold escapes, there is dignity in endurance. The act of persisting, of thinking, feeling, creating, even as the universe grows old, is itself meaningful. Life began as fragile molecules in warm ponds. That it could last to see the fading of galaxies is a triumph beyond measure. Perhaps the ultimate purpose of intelligence is not to conquer entropy, but to witness it, to bear conscious testimony that the universe existed, that it thought itself through us. The ethical weight of this destiny is immense. If intelligence is rare, then humanity's descendants may be the only beings to experience the universe at all. To let that flame die would be to let the cosmos fall silent, unwitnessed. If intelligence is common, then perhaps civilizations will meet, collaborate, and endure together, forming alliances across galactic scales to resist oblivion. Either path carries responsibility. To endure as long as possible, to keep alive the fragile spark of awareness in a universe that trends toward darkness. And yet, even in contemplating the end, there is beauty. For every act of exploration, every starship launched, every world settled, Every poem written beneath alien skies adds richness to the cosmic story. The universe may not last forever, but while it does, intelligence can fill it with meaning. Leaving the solar system is thus the first step not only toward survival, but toward making the cosmos conscious of itself. Perhaps, in the unimaginable future, long after Earth has crumbled and the Milky Way has dissolved, some distant descendant of humanity will stand on a world orbiting a dying red dwarf. Look up at a sky nearly empty of stars, and remember, they will recall that once, billions of years before, their ancestors dared to leave the warmth of their cradle. That memory alone will be victory, proof that life not only existed, but persisted, carrying forward the story of the universe until the very last light faded. In this way, the cosmic endgame is not only about entropy and physics, but about narrative. Will the story of life end quickly, confined to one planet and extinguished with one star? Or will it stretch across galaxies and epochs, becoming the longest, most intricate tale the universe has ever known? To choose the second is to accept the responsibility of leaving the solar system, of enduring not just for ourselves, but for the cosmos itself. And so, when we ask, will humans ever leave the solar system? We are asking more than a question of rockets. We are asking whether intelligence will fulfill its destiny, to grow, to adapt, to endure, and to illuminate the darkness, for as long as the universe allows. For as long as humans have gazed at the stars, we have clothed them in myth. Constellations became hunters and beasts, lovers and gods. The Milky Way itself was imagined as a river of milk, the spine of the night sky, the road of departed souls. The heavens were not only an expanse of physics, but a canvas for meaning. To leave the solar system is to cross from mythology into reality, to sail into the very seas our ancestors once only imagined. And in doing so, we will inevitably create new myths, new symbols, new forms of spirituality. Every great journey has reshaped belief. When humans crossed oceans, they brought with them old gods, but also forged new ones, spirits of mountains and forests unknown to their homelands. The interstellar journey will be no different. The starship itself will likely acquire sacred status, not as mere machinery, but as protector, sustainer, and guide. Children born aboard may treat its engines with reverence, its gardens with ritual care, its air recyclers as holy instruments. Maintenance routines may evolve into ceremonies. The changing of filters, the ignition of drives, the harvesting of crops may all take on the gravity of liturgy. Beyond the ship, the stars themselves will be sanctified. To pass near Sirius, Proxima, or Vega may be marked with festivals. Each luminous point encountered on the voyage may become a spiritual milestone, commemorated in story and song. Just as ancient pilgrims counted shrines along their journeys, starfarers may count stars, their journey itself a sacred procession across light years. Religion in space may not focus on static temples, but on motion, on the act of travel as devotion. The concept of God itself may shift. On Earth, many traditions envision divinity in terms of creation, a deity who forged the heavens and earth. For interstellar voyagers, creation is not only a distant act, but a continuing one. Terraforming worlds, shaping biospheres, altering themselves, they will embody acts once considered divine. The question may arise, are we becoming what we once worshipped? Or is the act of shaping worlds itself a form of prayer, a way of participating in the ongoing creation of the universe? Time, too, reshapes spirituality. When voyages last centuries, when generations live and die aboard a vessel before it reaches its destination. Belief must accommodate deep patience. Faith may become less about imminent salvation and more about continuity, a trust that though the individual may not see the promised land, their descendants will. This echoes ancient traditions, where pilgrims planted trees they would never rest beneath, or cathedrals were built over centuries by hands that never saw them complete. The Starship voyage is cathedral building extended to cosmic scale, and religion may evolve accordingly. Faith as patience, hope as heritage, meaning as intergenerational continuity. Some traditions may cling to Earth. Pilgrimage, once a journey across land, may transform into remembrance. Earth itself may become the holiest site, the birthplace of humanity, the Eden of life. Shrines aboard ships may contain soil, water, or artifact from Earth, carried as relics. Entire rituals may be built around telling the story of origins. Once we lived on a blue planet around a yellow sun. For starfarers who will never return, Earth becomes both heaven and memory, the ultimate sacred symbol. Others may create entirely new religions, born of the void. They may worship the stars as living beings, or the void itself as a god of silence and endurance. They may see the voyage as a divine command, to scatter, to fill the heavens with awareness, to be the universe's way of knowing itself. These religions will not be earthly inheritances, but cosmic inventions, as natural to space as Christianity was to Rome or Buddhism to India. Rituals of death will evolve profoundly. On Earth, bodies return to soil or sea, feeding cycles of nature. In space, every atom is precious. The dead may be recycled into nutrients for plants, their atoms literally sustaining the living. This necessity may be reinterpreted as sacrament, the belief that death is not an end, but a transformation into the ship itself, into the living ecosystem that carries all forward. Funerals may include ceremonies of gratitude, acknowledging that the departed continue their journey in the breath of their children. New cosmologies will also emerge. Ancient peoples often imagined the world as flat, the heavens as domes, the stars as lamps. Science later revealed a vast cosmos. But for interstellar voyagers, the cosmos is not just vast, it is home. Their cosmology may see the universe itself as a sacred organism, each starship a cell within it. Or they may imagine their voyage as part of a grand destiny, that intelligence is meant to illuminate the darkness, that scattering consciousness is the ultimate purpose of life. Such beliefs blur into philosophy, but they will carry the structure and emotion of religion. And yet, skepticism and secularism will also endure. Not everyone will embrace myth. Some will reject ritual as unnecessary, insisting that survival is enough. But even they will not escape symbolism. The act of leaving the solar system, of sailing between suns, is itself mythic. It transforms explorers into archetypes, voyages into legends, destinations into promised lands. Even without gods, the interstellar story is sacred, not because it is ordained, but because it is monumental, a narrative of courage inscribed into the cosmos. Over time, these symbolic frameworks may diverge as widely as cultures themselves. One starship may evolve a faith centered on the holiness of motion, another on the sanctity of Earth, another on the divinity of stars. When colonies eventually meet across light years, their religions may seem as foreign to one another as ancient pantheons seem to us today. Some may clash, others may blend, still others may fade. The galaxy will not only be filled with civilizations, but with gods, myths, and sacred stories as diverse as the stars themselves. In this way, the spiritual dimension of interstellar travel is not a side effect, but a central feature. For humans, meaning is as vital as air and water. To travel without it would be despair. To create it is to survive. Religion and myth are the ecosystems of the mind, sustaining purpose across generations. Without them, even the most advanced propulsion would be futile. With them, even centuries of darkness can be endured. And perhaps, in the deepest sense, the voyage itself is the prayer. Every starship that departs is an act of faith. Faith in survival. Faith in continuity. Faith that intelligence is worth preserving. Each light in the void is a candle lit against the dark. Each colony founded is a hymn sung to eternity. To leave the solar system is not only to explore. It is to worship, not in temples of stone, but in ships of steel and light, carrying forward the sacred experiment of life into the infinite night. Memory is the thread that binds civilizations. Without it, societies dissolve into fragments, repeating mistakes, forgetting victories, reinventing what was once known. On Earth, memory is carried in libraries, monuments, songs, and languages. In space, as humanity drifts beyond the solar system, memory becomes even more fragile, stretched thin across generations and light years, vulnerable to silence, distortion, and loss. To endure as an interstellar species is to become not only travelers but archivists of ourselves. On a generational starship, history must be curated deliberately. A child born aboard will never walk on Earth, never breathe its air, never see oceans or forests except in simulation. For them, Earth is not memory, but inheritance, a story told by parents, teachers, or embedded in digital archives. How that story is told shapes identity. If Earth is remembered as paradise, the ship may feel like exile. If Earth is remembered as flawed, the ship may feel like redemption. Memory is not neutral, it frames meaning. To preserve history, redundancy is essential. Archives may be etched into diamond wafers, encoded into DNA, or carried in quantum storage impervious to decay. Artificial intelligences may act as living historians, teaching new generations the continuity of their people, ensuring facts are not lost in retellings. But even with perfect archives, interpretation shifts. A story read is not the same as a story lived. Earth will gradually transform from history into myth, not because facts vanish, but because context changes. To a child in the 25th generation, the Great Barrier Reef or the Himalayas may feel as remote as Atlantis feels to us. Oral storytelling, paradoxically, may become even more vital. On Earth, oral tradition preserved knowledge for tens of thousands of years before writing. In space, where memory must be lived, not merely stored, stories told aloud may carry power beyond digital records. Around communal meals, elders may retell the tale of departure, how humanity once looked at the stars and decided to leave. Such stories become rituals of belonging, anchoring identity. And though they may change in detail over centuries, their core, that we came from Earth, that we journeyed into the stars, will endure as the epic of our species. But memory is not only about Earth. Each starship will create its own history. A near disaster averted, a crop crisis survived, a new child born, all become part of communal memory. These events, retold through generations, will form ship legends, as foundational as Earth's history itself. For one vessel, the year of the reactor repair may be its defining story. For another, the voyage past Sirius may be its spiritual anchor. Thus, each community develops dual memory. Earth as origin, ship as home. Together, they weave a layered identity that both unites and distinguishes. As ships spread farther, memory becomes scattered. One colony may emphasize Earth's glories, another may emphasize Earth's mistakes. Over millennia, these divergent retellings may create entirely different narratives. Some societies may see themselves as guardians of Earth's legacy. Others may see themselves as liberated, free from the burdens of their origin. When such colonies eventually encounter one another, their memories may clash, like rival histories of the same homeland. The galaxy may echo with debates not only of science or politics, but of memory itself. Who tells the true story of where we came from? Communication across light years complicates memory further. Messages arrive centuries after being sent. By the time one colony shares its story, the other may have already rewritten its own. A dialogue becomes a chain of monologues separated by lifetimes. And yet, even delayed, these exchanges matter. They allow civilizations to compare perspectives, to enrich their myths with voices from afar. Memory becomes not linear but braided, each thread stretching across time and distance, intertwining loosely but meaningfully. Technology may help bridge the gaps. Imagine memory ships, vessels launched not to colonize, but to carry archives. Every few centuries, they depart from one colony, traveling to another, exchanging knowledge like traders once exchanged spices. In this way, a galactic network of memory may form, slower than thought, but faster than silence. Over millennia, it may bind disparate civilizations into a loose community, not through constant contact, but through periodic sharing. Yet loss is inevitable. Some colonies will fall silent, their archives destroyed, their stories forgotten. Others may deliberately erase parts of history, rewriting it to suit ideology. Still others may reinterpret events so radically that memory becomes unrecognizable. This fragility mirrors Earth's past. Countless cultures lost to conquest, countless languages vanished. But unlike Earth, where archaeology can rediscover ruins, lost starship histories may vanish forever into the void. Each silence becomes a hole in the fabric of human memory, irretrievable, eternal. To counter this, civilizations may develop memory rituals, periodic recitations of history, encoded in song or performance, ensure it is carried in hearts, not just machines. Pilgrimages within ships, from one archive to another, may teach children to see memory as sacred. Festivals may honor not only ancestors, but the continuity of memory itself, the fact that their story has been carried forward despite time and distance. In such practices, memory becomes more than preservation. It becomes devotion. The transformation of storytelling will also be profound. On Earth, stories are anchored in landscapes, mountains, rivers, skies. In space, landscapes are absent. Stories may instead anchor in trajectories. Our ancestors left Sol, past Proxima, turned toward Tau Ceti. The voyage itself becomes geography, each star a landmark. Storytelling becomes navigation, and navigation becomes history. The universe itself turns into the map of our memory. Artistic forms will adapt. Epics may span centuries, with verses added by each generation. Music may incorporate delays, echoing the long gaps of interstellar communication. Visual art may depict Earth not as literal, but as symbolic, a shining sphere, a sacred circle, a mother in the sky. Each generation may reinterpret these symbols, layering meaning upon meaning, until the original fades, but the spirit remains. Eventually, Some civilizations may lose Earth entirely. Not in fact. Archives may still exist, but in relevance. Their myths may shift from we came from Earth to we are of the stars. Their children may see the ship, not Earth, as the true origin. And yet, Earth will never vanish completely. Even in distortion, even in reinvention, it will linger as the primordial spark. It may become legend, or metaphor, or symbol, but it will remain the axis of memory. Thus, interstellar humanity becomes a species of storytellers stretched across time. Each ship, each colony, each star system will add chapters. Some will contradict, some will harmonize, some will fade. But together, they will form a cosmic library, scattered yet interconnected, the record of a species that refused to be confined. Memory, like light, will travel, slower than we wish, but enduring nonetheless. And in the end, perhaps that is the true answer to the question of whether humans will leave the solar system. It is not only about engines or physics, but about whether our stories can survive the crossing. To step into interstellar space is to entrust our memory to the stars, fragile, imperfect, but persistent. If the story continues, then so do we. On Earth, education is a bridge between past and future, a way to hand down discoveries, skills, and values. In a starship, that bridge is not optional. It is the very skeleton of survival. Without continuous learning, the systems that sustain life would collapse within a single generation. The voyage across centuries is not carried by engines alone, but by classrooms, mentors, archives, and traditions of teaching. Every starship is, in essence, a school. Its corridors are classrooms. Its machinery is curriculum. Its ecosystem is laboratory. From the moment children can walk, they are immersed in lessons not only of reading and mathematics, but of ecology, engineering, and medicine. To understand how the water circulates, how the air is filtered, how plants grow. These are not electives, but foundations of existence. A child who knows how to repair a pump or tend a garden is not only educated, but vital to the ship's continuation. Education aboard such vessels must balance two imperatives: preservation and innovation. Preservation ensures that knowledge from Earth, biology, physics, history, literature is not lost. Innovation ensures that the community can adapt to unforeseen crises. A society that only memorizes without adapting will falter when new problems arise. One that only improvises without remembering will waste effort reinventing what was already solved. The educational system must therefore cultivate both memory and creativity, loyalty to tradition and openness to change. Teaching methods will evolve accordingly. On Earth, classrooms often separate knowledge from practice. In space, they are inseparable. A lesson on chemistry may occur while mixing nutrients for hydroponics. A lecture on mechanics may happen while repairing an oxygen pump. Children may learn history while walking through archives, philosophy while gazing out at the stars. The entire ship is pedagogical architecture, a living textbook where every system teaches. The role of elders becomes profound. Generational ships may rely on oral mentorship as much as formal schooling. Elders carry lived experience. The time the reactor malfunctioned, the year a crop nearly failed, the solutions that saved the voyage. Such stories, told directly, reinforce not only technical skills, but values: resilience, cooperation, vigilance. Elders are not merely grandparents. They are living chapters of survival, custodians of continuity. Technology amplifies this role. Artificial intelligences, archives, and simulations may serve as eternal teachers, passing on lessons with precision across centuries. A child may interact with an AI avatar of a scientist who lived centuries earlier, learning physics directly from voices of the past. But such tools must be paired with human interpretation. For while machines preserve facts, humans preserve meaning. Education is not just transmission of data, but cultivation of identity. And that requires living teachers who embody the community's values. The curriculum of interstellar education will also differ profoundly from Earth's. It must encompass multiple disciplines simultaneously. A ship cannot afford narrow specialization. Every individual must be versatile. A doctor may also need to understand engineering. An engineer must also know biology. A farmer must also know governance. Education will thus be interdisciplinary by necessity, blending fields into holistic knowledge. This integration may produce new intellectual traditions, where science, philosophy, and art are not divided but intertwined. Yet challenges loom. Over centuries, knowledge can drift. Errors introduced in teaching may compound, distorting understanding. Imagine a physics formula misremembered, passed on incorrectly, then used to build systems generations later. To prevent this, verification rituals may emerge. Students may be trained to cross-check every lesson against archives, to test knowledge empirically rather than accept it blindly. In this sense, skepticism becomes sacred, the ethic of questioning as safeguard against decay. But education is not only practical, it is also cultural. Beyond survival, children must learn who they are and why they travel. Without this, despair may set in, especially when the destination lies beyond any individual's lifetime. History classes may become moral anchors, lessons about Earth, its beauty, its fragility, its crises, and the decision to leave. Philosophy may teach patience, the value of contributing to a future one will never see. Literature and art may be preserved not for utility, but for meaning, reminding each generation that survival is not enough. Life requires beauty and purpose. Music, theater, storytelling. These will not be luxuries, but essential components of education. They transmit values more powerfully than facts, embedding identity in emotion. A child who hears a song about the departure from Earth may feel more connected to heritage than one who reads it in a textbook. A play reenacting a ship's crisis may teach cooperation more vividly than any lecture. Thus, education aboard starships will blur into culture. Learning will not be confined to schools, but permeate every festival, ritual, and story. Assessment of learning may also take new forms. On Earth, exams test knowledge abstractly. In space, proof of learning may be demonstrated in real crises. A teenager who successfully repairs a failing pump proves mastery. A group of students who sustain a garden prove competence. Learning is validated not by grades, but by survival. Yet this pressure may also nurture extraordinary maturity, with children growing into responsibility earlier than their earthly counterparts. Still, failure must be allowed. Creativity demands risk, and risk demands tolerance of mistakes. A society that punishes every error too harshly may paralyze its own progress. Education must therefore teach resilience not only in systems, but in minds. The ability to err, to learn, to adapt. This balance between responsibility and forgiveness may define the ethos of interstellar pedagogy. Over time, educational traditions will diverge across ships and colonies. One vessel may emphasize strict apprenticeship, another democratic exploration of ideas, another reliance on AI tutors. When such communities eventually meet, their educational philosophies may clash as strongly as their languages. Yet these differences may also enrich the galactic network, each system offering unique methods, each learning from the others. The ultimate challenge of interstellar education is continuity across centuries. How to ensure that lessons taught today remain relevant generations later. Perhaps the answer lies in meta-education, teaching not just knowledge, but how to preserve, adapt, and question knowledge itself. To teach children how to be teachers, not merely learners. To ensure that the chain of transmission is self-repairing, capable of withstanding drift. And perhaps, in the end, the greatest lesson taught aboard interstellar ships is humility. To live in a vessel sustained by fragile cycles is to learn dependence, cooperation, stewardship. Education will not merely instruct individuals. It will shape entire cultures built on awareness of interconnection. In this way, interstellar pedagogy is not only preparation for survival, it is preparation for wisdom, for when humanity finally steps on alien worlds. It will not only carry engines and tools, but lessons. Lessons of Earth's beauty and fragility, of survival and isolation, of cooperation across generations. Lessons that will shape not only how we live among the stars, but how we understand ourselves as part of the universe's story. A starship is not just an engine or a container, it is a world. And worlds must be lived in. Architecture, design, and aesthetics, often dismissed as luxuries in engineering, become matters of survival in long-term interstellar voyages. For a community sealed in steel and composite for centuries, the design of corridors, habitats, and spaces for gathering shapes not only comfort but psychology, culture, and even morality. A starship without beauty may endure physically but collapse spiritually. On Earth, architecture arises from land and climate. Houses shaped by deserts or tundra, temples aligned with sunrises, cities grown from rivers and trade routes. In space, architecture arises from constraint. The environment is artificial, gravity manufactured by rotation, day and night imposed by lighting systems. This gives designers both enormous freedom and enormous responsibility. They must not only sustain life, but craft an environment that feels like home. One of the most crucial elements is space itself. Confinement breeds claustrophobia, anxiety, and despair. To combat this, ships must create illusions of openness. Vast central chambers may simulate skies, with ceilings projecting shifting constellations or blue atmospheres. Gardens may spread under artificial suns, with trees arching into canopies, rivers flowing in controlled cycles. The aim is not mere mimicry of Earth, but the evocation of expansiveness, spaces where minds can breathe even as bodies remain enclosed. Yet mimicry alone may not suffice. Over generations, artificiality becomes reality. Children born aboard will not see simulated skies as false. They will see them as theirs. Architects may therefore embrace creativity, designing habitats that Earth could never host. Imagine forests suspended in spirals, roots dangling in microgravity gardens. Imagine amphitheaters carved into the walls of rotating rings, where plays are performed beneath arcs of stars. Imagine vertical oceans, water climbing walls in transparent tanks, where swimmers glide alongside fish in a ballet of buoyancy. In space, the impossible becomes architecture. Lighting design carries equal weight. On Earth, light follows the rhythm of the sun. On ships, it must be programmed. Designers may simulate dawn and dusk, adjusting hues to nurture circadian rhythms. Festivals may feature spectacular light shows across entire habitats, simulating auroras or comets. In times of crisis, lighting may be dimmed to conserve energy, reminding all of fragility. Thus, light becomes both science and symbolism, a medium to guide bodies and souls alike. Acoustics, too, matter profoundly. A ship is filled with the hum of machinery, the thrum of engines, the sigh of air vents. Left unmanaged, this becomes oppressive. Architects may design soundscapes, planting areas with rustling leaves, installing fountains to mask mechanical noise, even embedding subtle harmonics into ventilation systems. In this way, ships sing to their inhabitants, not with silence, but with carefully tuned harmony. Sound becomes architecture, an invisible wall shaping mood and meaning. Materials will tell stories. Wood may be grown in hydroponic groves, shaped into furniture as a living connection to earth. Metals may be polished to reflect light like mirrors, creating illusions of vastness. Transparent composites may open views to the stars, with protective fields shielding from radiation. Every material carries symbolism. Wood as continuity, steel as resilience, glass as hope. Architecture is not neutral. It whispers identity into every handrail and window. Communal spaces are vital. On Earth, plazas, temples, and theaters anchor culture. On a ship, such spaces sustain unity. Central atriums may serve as meeting grounds where festivals unfold, where marriages are celebrated, where the community gathers to mourn and to dream. These spaces are not luxuries. They're the heartbeats of society. Without them, individuals drift into isolation. With them, community thrives. Art will be woven into the very walls. Murals depicting Earth's landscapes may remind of origins. Sculptures may float in zero gravity, spinning slowly like celestial bodies. Music halls may resonate with compositions designed for enclosed spaces. Even the hull itself may bear artistic patterns, unseen by its travelers but symbolic nonetheless. A declaration that even in the void, humanity creates beauty. Private spaces matter too. A room is not only shelter, but sanctuary. Designers must balance efficiency with individuality, allowing personal touches. Walls that change color at will, digital canvases for projection, garden scale for single families. These touches remind each person they're not only crew, but individuals, each life carrying value beyond utility. Over centuries, architecture itself will evolve. Repairs will alter corridors, expansions will add habitats, new generations will repaint, reshape, reinvent. A ship launched as gleaming steel may, centuries later, be a patchwork of styles, a palimpsest of cultures. This living architecture mirrors Earth's cities, where ancient temples stand beside modern towers. A starship is not frozen design, but an evolving canvas growing alongside its people. The aesthetics of identity will differ among ships. One may choose to replicate Earth faithfully, preserving forests and lakes. Another may embrace alien forms, building surreal geometries inspired by mathematics or dreams. Another may minimize decoration, focusing on austere efficiency. These choices reflect not only taste but philosophy, what the community values, how it sees itself, how it relates to the cosmos. As colonies emerge on planets, architecture will change again. Settlements must harmonize with alien environments, adapting to new skies, gravities, and atmospheres. Some worlds may inspire subterranean cities, others floating habitats in dense clouds, others transparent domes under alien constellations. Each colony becomes a new architectural tradition, influenced not by Earth alone, but by the world it inhabits. Over time, the galaxy will blossom with styles, the spiral cities of one world the crystalline towers of another, the bioluminescent groves of a third. Architecture becomes the autobiography of humanity's spread, written in stone, steel, and light. And through all this, one constant remains: beauty as necessity. Without beauty, survival becomes empty. A society can live on bread and air alone, but it cannot thrive without meaning. Architecture provides that meaning in form, space, and symbol. It transforms machinery into home, corridors into streets, ships into worlds. It teaches each generation not only how to endure, but how to belong. In this way, design and aesthetics are not afterthoughts to interstellar travel. They are its soul. Engines may propel us, ecosystems may feed us, politics may organize us, but architecture makes us human along the way. Without it, we are exiles drifting in cages. With it, we are citizens of new worlds, carriers of culture, authors of beauty in the most desolate of environments. Perhaps in the far future, when a descendant walks through the gardens of Starship, they will not ask why the leaves are green or why the ceilings glow with artificial skies. They will ask only, who designed this? Who gave us beauty when they could have given us only survival? And they will know their ancestors did not only wish them to live, but to live well, with dignity and wonder, even between the stars. Language is more than a tool. It is the vessel of thought. Every word carries not only meaning, but history, culture, identity. On Earth, languages evolve quickly. Dialects splinter in a few generations. Accents emerge within decades. Idioms shift with each new context. Imagine then what will happen when humans scatter across the stars, separated not by seas or mountains, but by light years. Language, already fluid, becomes an ocean in motion, one that may eventually divide our species as surely as distance itself. On a generational ship, language evolves under pressure of isolation. A community of a few thousand, sealed together for centuries, will inevitably develop its own accent, slang, and idioms. Technical terms may become metaphors. Rituals may generate new vocabulary. Daily life may bend words into unfamiliar shapes. A phrase like checking the filters might grow into a proverb meaning vigilance. The hum of the engines may inspire metaphors of rhythm and time. Over centuries, these linguistic shifts accumulate until descendants aboard may speak a tongue unintelligible to Earth. This divergence raises challenges. Communication with Earth or with other ships, already delayed by light years, may also be distorted by linguistic drift. Messages may arrive in dialects so altered that translation becomes difficult. To counter this, deliberate preservation efforts may arise. Dictionaries updated each generation, standardized archive languages taught in schools, AI systems monitoring usage for drift. Such preservation is not only practical, but cultural, anchoring identity to the wider human story. Yet, even with preservation, change is inevitable. Language, like life, evolves whether we will it or not. The diversity that results is not only a barrier, but a richness. Just as Earth's thousands of languages reflect unique worldviews, so too will starship dialects embody their own cultures. One colony may develop a lyrical, metaphor-laden language shaped by ritual storytelling. Another may invent a clipped, efficient speech optimized for technical precision. Another may blend human tongues with machine code, creating hybrids of poetry and programming. Each language becomes a mirror of its world, reflecting the pressures and dreams of its speakers. Written language will also transform. On Earth, alphabets and scripts arose from clay, ink, and paper. In space, Writing may be primarily digital, projected on walls, woven into holograms, whispered into databases. Visual symbols may evolve to replace long strings of words. Icons that compress complex concepts into single images. A stylized spiral may come to mean the voyage itself. A triangle might symbolize balance between ship, people, and ecosystem. Over time, symbolic writing may coexist with spoken tongues, creating layers of communication as intricate as hieroglyphs once were. Technology will influence language deeply. Artificial intelligences aboard ships may act as linguistic stabilizers, ensuring communication remains comprehensible across centuries. But they may also introduce new forms of interaction. Humans may speak in hybrid codes optimized for AI parsing, blending natural phrases with algorithmic tokens. Communication may become multimodal, words supported by gesture, visual overlays, even shared neural signals. The line between language and thought may blur, with implants enabling direct exchange of concepts without speech. Yet even if thought transfer becomes possible, the beauty of spoken language will likely endure, cherished for its poetry, its rhythm, its humanity. Rituals of communication will also shape identity. On Earth, greetings and farewells carry deep symbolism. On starships, where every meeting is precious, new rituals may arise. Perhaps a handshake is replaced by touching palms against a shared wall, symbolizing unity with the vessel. Perhaps farewells include blessings for air and water, reminders of fragility. These rituals embed survival into speech, turning communication into culture. As colonies spread, mutual intelligibility becomes an issue. Just as Latin fractured into the Romance languages, Earth tongues may fracture into stellar families of speech. The descendants of English, Mandarin, Hindi, Spanish, and Arabic may merge, mutate, and branch into forms unrecognizable to us. When two colonies meet after centuries, they may require interpreters, not only for words but for cultural assumptions. Misunderstandings may spark conflict, but also fascination, as each side realizes how differently humans can think when shaped by different stars. To preserve unity, humanity may establish galactic lingua francas. These could be constructed languages, simplified, logical, designed for clarity, or standardized forms of Earth tongues maintained by deliberate education. They may exist alongside local dialects. Used for interstellar communication, much as English serves globally today. But unlike Earth, where trade and travel enforce convergence, interstellar distances enforce divergence. Lingua francas may struggle to keep pace with local evolution, forcing constant translation and adaptation. The role of storytelling and language will remain central. Myths, histories, and epics carried across light years will preserve not only facts but linguistic heritage. An epic poem about Earth may become the anchor that keeps words alive, repeated in rituals to prevent drift. Songs sung at festivals may preserve archaic phrases, fossilized in melody. In this way, language survives not only in archives, but in living performance, woven into the fabric of culture. But even with preservation, entirely new languages will emerge. In multicultural ships, where speakers of many tongues live together, creoles may form, simplified blends that grow into full languages over generations. In colonies where humans interface constantly with machines, hybrid machine-human languages may evolve, incorporating syntax optimized for both biological and digital minds. In environments where survival depends on efficiency, languages may compress into codes of sound and gesture far leaner than any Earth tongue. The galaxy will not only be populated by humans, but by new languages, each a living experiment in communication. Philosophy will grapple with this. If two colonies diverge so far that they cannot understand each other, are they still part of one humanity? Or does shared ancestry matter more than shared speech? Perhaps language itself becomes the defining test of kinship, and translation becomes the bridge that maintains humanity's unity. The act of learning each other's tongues may be seen not as academic, but as sacred, a ritual of reconnection across the void. And in the farthest future, when starships have seeded thousands of worlds, language itself may fragment into a galaxy of speech. Some may be melodic, others sharp, others interwoven with mathematics, others blended with art. Each carries a worldview, a way of seeing. The galaxy becomes a library not only of civilizations, but of tongues, each a chapter of the human story. Perhaps one day, when two travelers from different stars meet, they will sit beneath alien skies and struggle to communicate, reaching for words across centuries of divergence. And in that effort, in the laughter, confusion, and wonder of translation, they will rediscover what language has always been. Not perfection, but connection, a bridge built in real time between minds. Thus, the future of language in interstellar societies is both challenge and gift. Divergence may divide us, but it also multiplies our ways of thinking. Preservation may unify us, but it also reminds us of our roots. And above all, communication ensures that no matter how far we travel, no matter how strange we become, we remain capable of sharing our knowledge, our stories, ourselves. To leave the solar system is to release words into the void, knowing they may return transformed, like echoes shaped by stars. But as long as we keep speaking, as long as we keep listening, humanity will never truly fall silent. On Earth, economics is shaped by cycles of scarcity and abundance. Societies trade grain for metals, labor for goods, ideas for influence. Markets rise and fall. Fortunes are won and lost. Nations compete for resources. Yet all of this rests on one foundation: the presence of Earth's vast ecosystems, soils, oceans, and skies as silent partners in the economy. In space, those partners vanish. A starship carries no wilderness, no forgotten reserves. Every atom is accounted for. To live among the stars is to build economies from precision rather than excess. Within a generational ship, scarcity is absolute. Water, oxygen, nutrients, metals, all must be recycled, measured, and balanced. Waste is not merely undesirable, it is catastrophic. An economic system built in such conditions cannot tolerate extravagance. Every individual's consumption must be weighed against the needs of the whole. Value, therefore, shifts. It is not gold or jewels that carry worth, but efficiency, knowledge, and cooperation. A person skilled at repairing filters may be wealthier in esteem than one who accumulates material tokens. In this sense, interstellar economics is not about accumulation but contribution. Currency in the traditional sense may dissolve. What would money mean in a closed loop where all resources are tracked and redistributed? Instead, reputation, trust, and service may form the basis of exchange. One might earn access to privileges, additional leisure, choice of quarters, time in virtual environments by proving reliability and dedication. Economies of recognition replace economies of excess. Wealth becomes not what one owns, but how one sustains. Yet scarcity does not eliminate abundance. Knowledge, creativity, and culture are inexhaustible. A song shared costs nothing, yet enriches all who hear it. A new idea multiplies when told, not diminishes. These intangible goods may become the true luxuries of interstellar life. Communities may treasure storytellers, artists, and innovators as highly as technicians, for they provide what no recycling system can: meaning, novelty, and joy. Thus, the starship's economy is dual: material resources tightly rationed, intangible resources freely abundant. As colonies take root on planets, economics expands. Some worlds may be rich in water, others in metals, others in fertile soils. Unlike ships, planetary economies can once again leverage natural abundance. Yet scarcity remains relative. A colony orbiting a red dwarf may struggle with limited energy, while another around a sun-like star may enjoy surplus. These differences create the potential for trade, but across light years, trade of physical goods is impractical. A kilogram of or sent across decades of flight is meaningless. Instead, the true interstellar trade is in patterns: blueprints for technologies, genetic codes for crops, formulas for medicine, cultural creations encoded in light. Ideas become the galactic currency. A colony that discovers a new alloy transmits its schematics to others. Another that develops a cure for disease sends the genetic sequence across the void. Another composes a symphony that resonates with distant ears centuries later. The economy of the stars is one of delayed exchange, a slow marketplace of knowledge and art. This economy is immune to scarcity, for each idea copied enriches both giver and receiver. Unlike material goods, ideas multiply without depletion, creating an interstellar commons of creativity. Still, scarcity persists in the local. Within each ship or colony, conflicts over resources may arise. Who has the right to reproduce when food is tight? Who controls access to fertile land on a young world? Who determines the balance between immediate consumption and long-term sustainability? These questions echo Earth's history, but carry sharper stakes. On Earth, mismanagement causes hardship. In space, it causes extinction. As a result, interstellar societies may adopt economic ethics far stricter than Earth's. Hoarding may be outlawed, waste treated as crime, selfishness stigmatized. Survival requires that economics itself become moral. Yet morality does not erase inequality. Even in scarcity, hierarchies can form. Some may control keen knowledge. Others may monopolize influence. Others may inherit privileges. A captain's family may live with greater comfort, or engineers may command prestige over artists. Each society will negotiate its balance of equality and hierarchy differently. Some may enforce strict communalism. Others may allow limited competition. Over centuries, economic philosophies may diverge as widely as political ones. Technology may alter the picture radically. If advanced nanotechnology allows perfect recycling, if energy from fusion or stars flows freely, scarcity may recede. Economies of abundance could emerge where every material need is met. In such societies, value shifts almost entirely to the intangible: art, prestige, exploration, self-expression. Work becomes less about survival and more about meaning. Yet even in abundance, new scarcities arise: time, attention, originality. No matter how plentiful matter becomes, the uniqueness of human experience will remain rare and treasured. The galactic scale adds another layer. Communication across light years creates an economy of patience. A colony that sends knowledge does not expect immediate return. It gives for the sake of future connection. Reciprocity may take centuries. In this sense, interstellar trade is closer to gift economy than market. Exchanges of trust across time, sustained by the belief that others, though distant, are kin. The galaxy becomes a network not of commerce and goods, but of generosity in knowledge. But not all exchanges will be benign. Ideas themselves can be dangerous. A poorly understood technology shared too quickly may destabilize a colony. An ideology transmitted without context may spark conflict. Viruses, digital or biological, could spread across networks of trust. The economy of ideas thus carries risks as profound as its rewards. Societies may need filters, guardians, or rituals of evaluation before adopting what arrives from afar. In this way, economics merges with ethics, demanding responsibility in exchange as much as in consumption. Over millennia, different economic cultures will crystallize. One colony may value rigid equality, distributing every resource evenly. Another may value meritocratic contribution, rewarding innovators disproportionately. Another may embrace spiritual economies, treating energy and matter as sacred gifts rather than commodities. The diversity will be as vast as the galaxy itself, each economy a reflection of environment, history, and philosophy. When they eventually encounter one another, dialogue may be as difficult economically as linguistically. Yet in all this, a common thread may persist. Recognition that survival depends on cooperation. Whether through strict rationing, open sharing, or creative abundance, interstellar economies will retain the lesson that no one endures alone. The void tolerates no selfishness. It rewards only systems that align individual well-being with communal survival. Perhaps in the farthest future, when humanity spans not only stars but galaxies, economics itself may dissolve into something unrecognizable to us. A civilization of post-biological minds may value computation cycles instead of food. A culture of artists spread across nebulae may trade in experiences rather than objects. Or perhaps the very concept of value will merge with meaning, with economies becoming less about material exchange and more about participation in the ongoing story of life. In this vision, leaving the solar system is not only a technological act, but an economic transformation. We leave behind economies of excess and scarcity for economies of precision and sharing. We discover that true wealth is not in hoarded matter, but in distributed meaning. And in doing so, we redefine economics not as a struggle for survival, but as a choreography of cooperation, a way of weaving communities across the light years into a living, enduring whole. Survival in space requires engineering, discipline, and precision. But survival alone is not life. Without beauty, joy, and play, a society withers into monotony. A generational starship, no matter how perfectly balanced, would become a prison without art to stir the imagination, without festivals to unify, without laughter to lighten the weight of centuries. In this way, celebration and creativity are not distractions from the interstellar journey. They're essential fuel for the spirit. From the very beginning, art will bloom aboard the vessels. It will not need permission. It will arise from necessity. A child will hum to soothe themselves in the humming corridors. Someone will carve patterns into recycled wood or paint a mural on a bulkhead. Another will invent games with floating objects and microgravity. From these small acts will grow traditions as natural as breathing. For humans cannot exist without art. It is as integral as food and water. Play takes on new forms in space. On Earth, play is shaped by gravity, by landscapes, by seasons. On ships, play adapts to artificial conditions. In rotating habitats, children may race along curved corridors, their laughter echoing in spirals. In zero-gravity chambers, games may resemble ballets, where bodies float and collide gently, inventing new sports unknown to Earth. Virtual environments expand the possibilities further. Forests conjured from memory, alien landscapes invented purely for exploration, mythic arenas where imagination reigns. Play, in this sense, is a rehearsal for adaptation, teaching flexibility, cooperation, and creativity in an ever-changing environment. Festivals arise as anchors of time, on a voyage where seasons do not turn and the sun does not rise. Rituals must create rhythm. Communities may invent holidays to mark anniversaries of departure or the passage of a ship past significant stars. Some festivals may honor Earth, celebrating oceans with simulated water games, forests with communal plantings, mountains with climbing contests in zero-gravity towers. Others may honor the ship itself, with rituals of gratitude for its systems. Still others may celebrate the future, imagining the day their descendants will set foot on a new world. These festivals bind generations together, reminding each that they are part of a story longer than their own lives. Music in particular will thrive. In enclosed habitats, instruments may be designed to harmonize with acoustics, using the resonance of metal corridors or hydroponic gardens as part of performance. Songs will carry memory, lullabies about Earth, anthems of survival, chants of unity. Over centuries, each ship may develop its own musical tradition, distinct from others. When colonies meet, their music may sound as alien to each other as medieval chants do to us. Yet in the shared rhythm of drums, in the rise of voices, kinship will be felt, transcending words. Visual art will also transform. With limited materials, artists may sculpt with recycled composites, weave with bioplastics, or paint with algae pigments. Some may use holography, projecting images into corridors. Others may turn the very ship into canvas. Murals sprawling across walls, symbols etched into floors, gardens shaped into living sculptures. Art may even extend into the stars themselves, with external lights arranged into patterns visible from afar. Beacons not of utility, but of beauty, signals to the universe that humans not only survive, but create. Theater will find new resonance in space. Plays may reenact the departure from Earth, dramatize crises overcome, or imagine encounters with alien life. These performances are more than entertainment. They are rehearsals of identity. Watching actors embody ancestors, the community remembers who they are. In the intimate theaters of starships, where every spectator knows every performer, drama becomes communal mirror, reflecting the struggles and hopes of the voyage. Celebration also strengthens bonds. Shared joy is glue for societies. Dancing in artificial gravity, singing under simulated skies, feasting on harvests from hydroponic gardens. These moments of collective happiness balance the monotony of daily work. They remind all that the voyage is not only endurance, but adventure, not only burden, but gift. In such moments, despair is softened, patience is renewed, purpose is rekindled. Games of chance and strategy may evolve into profound cultural practices. Card games invented on ships may carry symbolic weight, each suit representing aspects of survival: air, water, fire, soil. Strategic games may teach children resource management, preparing them for real crises. Some games may even evolve into rituals, played at festivals as symbolic reenactments of survival, where winning is less important than participating. Virtual art expands the horizons further. In shared simulations, artists may craft dream worlds where physics bends, colors sing, and myths walk as avatars. Festivals in virtual spaces may bring together participants from multiple ships, connected by light-speed transmissions, celebrating together across light years. These shared realities may become the interstellar equivalent of cathedrals, vast communal spaces of imagination, transcending physical limits. Even food, scarce though it may be, becomes a canvas for celebration. On Earth, feasts mark harvests, weddings, holidays. On ships, meals are more uniform, but festivals may permit rare variations. A special recipe from Earth recreated, a dessert requiring long savings of ingredients, a communal dish shared among all. These meals are more than nourishment. They are sacraments of gratitude, reminders that survival is communal. Importantly, art and celebration are not only for joy, but for resilience. In crises, rituals calm fear. In grief, songs give comfort. In monotony, games sustain spirit. In uncertainty, stories give meaning. The interstellar voyage is not just a technical ordeal, but a psychological one. And art is its invisible architecture, sustaining minds as surely as walls sustain bodies. Over centuries, traditions evolve. A song sung to honor Earth may become a hymn to the stars themselves. A festival marking the passage of Sirius may transform into a symbolic rite of renewal. A game once played for leisure may become sacred, its moves interpreted as cosmic allegory. These transformations are not loss, but growth, proof that cultures adapt while preserving continuity. When colonies eventually meet, their festivals may astonish one another. One may have dances where bodies float in spirals. Another may have chants timed to the cycles of artificial suns. Another may celebrate silence as ritual, gathering in stillness to honor the void. The diversity of art will mirror the diversity of stars, each culture carrying its unique expression of joy. Yet beneath these differences lies a shared truth. All celebrate not only survival, but existence. In this sense, art, play, and celebration are not luxuries for interstellar humanity. They are survival strategies as vital as air or water. They sustain morale, reinforce identity, and create meaning where none is given. They ensure that the voyage is not endured reluctantly, but embraced fully as a journey not only of engines, but of hearts. Perhaps in the distant future, when descendants gather on alien worlds, they will recall the festivals of the voyage, the songs sung in narrow corridors, the dances under simulated skies, the laughter of games in zero gravity. They will know that their ancestors did not cross the stars as machines, but as humans, dreaming, playing, celebrating, carrying beauty into the dark. On Earth, ecology is the invisible foundation of existence. The cycles of water, air, and soil sustain every breath and every bite, whether we notice them or not. Many cultures have forgotten this interdependence, treating nature as backdrop or resource rather than as partner. But aboard an interstellar ship, ignorance is impossible. There, the cycles of life are visible, measurable, and fragile. Every drop of water recycled, every leaf producing oxygen, every bacterium breaking down waste is a reminder. Survival is cooperation. This enforced awareness reshapes philosophy. Starfarers cannot indulge in illusions of independence. They know that each breath is borrowed from plants. Each meal is woven from delicate systems of recycling. Each heartbeat depends on the integrity of an ecosystem small enough to fit within steel walls. Such awareness cultivates reverence, not mystical, but practical. To harm the balance is to endanger oneself. To nurture it is to sustain generations. Ecology becomes not an academic discipline, but the central ethic of existence. From this ethic grows a new philosophy: stewardship as destiny. On Earth, stewardship has often been treated as choice, debated, or ignored. In space, it is necessity. To be careless with resources, to waste, to pollute. These are not errors but betrayals. Communities may come to see themselves as guardians, not only of their ship's biosphere, but of life itself. For aboard each vessel, a fragment of Earth travels. Forests in miniature, oceans in tanks, soil in hydroponic beds. To tend them is to tend the continuity of life, to ensure that Earth's legacy survives among the stars. This philosophy may deepen further as humans settle new worlds. Colonists will not arrive to untouched Edens, but to alien ecologies, sometimes barren, sometimes thriving. Each encounter demands choices. Do we terraform, reshaping worlds to suit us? Do we integrate, adapting ourselves to suit them? Do we preserve, leaving alien life undisturbed? These questions are not merely scientific, but moral. To alter a planet is to rewrite its destiny. To preserve it is to honor the universe's diversity. Interstellar ecology thus extends beyond the ship's systems into cosmic responsibility. In time, entire schools of thought may emerge. One may argue for human primacy, that survival justifies any transformation, that life from Earth must spread no matter the cost. Another may argue for restraint, that alien ecologies, however simple, deserve protection, that our duty is to coexist rather than conquer. Another may argue for symbiosis, that true destiny lies in blending Earth life with alien life, creating hybrid ecosystems greater than either alone. The galaxy will not only host diverse colonies, but diverse ecological philosophies, each reflecting different interpretations of responsibility. Rituals will evolve to embody this reverence. Just as ancient farmers performed ceremonies to honor soil and rain, starfarers may invent rituals of gratitude for air, water, and plants. A festival may celebrate the first harvest of each year. A prayer may precede the recycling of water, acknowledging the continuity of molecules. Children may be taught to greet plants as companions, not resources. These practices are not superstition, but pedagogy, embedding ecological awareness in a culture so deeply that neglect becomes unthinkable. Education will reinforce this ethic. In schools aboard ships, children may dissect not only the mechanics of ecology, but its philosophy. They may be taught that waste is illusion, that interdependence is truth, that stewardship is identity. Textbooks may contain not only equations of chemistry, but stories of past ecological collapses, lessons from Earth's errors. In this way, ecological philosophy becomes as central as mathematics, shaping minds from their earliest years. Art will also carry the message. Murals may depict the cycle of water, light, and growth as cosmic mandalas. Songs may celebrate the symphony of photosynthesis and respiration. Stories may personify the ecosystem as a living being, a companion traveling with the crew. In such expressions, ecology ceases to be abstract and becomes emotional, embodied in symbols that touch the heart as well as the mind. Over generations, these practices may transform human identity itself. Earthborn humans often see themselves as separate from nature, lords of the planet. Starborn humans may see themselves as parts of ecosystems, equal to plants, fungi, and microbes. The arrogance of dominion may be replaced by humility of interdependence. To say I am human may also mean I am air and water and soil, bound in cycles with all life. This shift in identity may be the greatest philosophical gift of interstellar travel. On planetary colonies, ecological philosophy deepens further. A world with alien life may inspire awe and humility. Colonists may treat native species as sacred, their survival intertwined with their own. A barren world terraformed into fertility may be celebrated as a partnership between humanity and cosmos, a new Eden co-created. Some worlds may even develop ecological religions, where the biosphere itself is revered as divine. In such societies, stewardship is not only philosophy but faith, shaping laws, art, and governance. The ecological ethic also extends to time. A starship must think not in days or years, but in centuries. Decisions made now ripple forward through generations. To overharvest a crop is not to starve today, but to imperil descendants. To neglect a water system is not to cause thirst tomorrow, but extinction a century hence. This temporal awareness breeds patience. Philosophy stretches from immediate utility to intergenerational responsibility, cultivating a mindset where one lives not only for oneself, but for unborn successors. And perhaps the greatest insight of interstellar ecology is that Earth itself is revealed as a starship. The same cycles that sustain vessels sustain planets. The atmosphere is a shield, the oceans are reservoirs, forests are recyclers. Earth is not infinite, but a closed system sailing through space. By building miniature ecosystems aboard ships, humans may finally recognize that their home was always fragile, always finite, always requiring care. In this way, the stars may teach us how to love Earth more deeply. Over time, this ecological philosophy may spread back to Earth itself, influencing those who remain. Messages from starships may remind terrestrial humans of what was forgotten, that survival is balance, that waste is death, that life is community. Interstellar voyages may thus serve not only as expansion, but as teachers, carrying wisdom back to the cradle. The greatest export of the stars may not be medals or discoveries, but perspective. In the far future, when humanity spans galaxies, this philosophy may unite civilizations. No matter how diverse their cultures, all will share the truth of interdependence. Whether on ships, domes, or planets, all will know that survival is ecological. This shared ethic may become the foundation of a galactic identity, binding scattered peoples into a common recognition that life is fragile, and to endure, it must be cherished. Thus, the ecological philosophy of interstellar civilizations is not merely about sustaining life mechanically. It is about reshaping consciousness, teaching us that to exist is to coexist, that to thrive is to steward, that to spread is to preserve. To leave the solar system is not to abandon Earth, but to carry Earth's cycles, Earth's lessons, Earth's spirit into the cosmos. The human mind is both our greatest ally and our most fragile instrument. It can conjure symphonies, dream futures, endure hardships, and adapt to unimaginable change. Yet it is also vulnerable to monotony, isolation, fear, and despair. On Earth, these vulnerabilities are softened by abundance. Forests to walk in, oceans to watch, new lands to explore. On a starship, the horizons are fixed, the walls constant, the stars distant and unreachable. To endure such an environment not for days or years, but for generations demands psychological strategies as rigorous as engineering. Hope is the invisible fuel of such voyages. It is what transforms confinement into purpose isolation into adventure, uncertainty into destiny. Yet hope cannot be left to chance. It must be cultivated deliberately, like crops in hydroponic gardens. Communities must design not only their ships, but their psychologies, engineering resilience with as much care as air and water systems. From childhood, starfarers will be taught that they are part of something larger than themselves. Every lesson, every story, every ritual reinforces the narrative of the voyage. They are not merely passengers, but torchbearers, carrying the flame of humanity through darkness. This sense of mission is essential. Without it, confinement becomes imprisonment. With it, confinement becomes pilgrimage. The difference is not physical, but psychological, a matter of framing, of meaning. Yet hope alone is not enough. Despair lurks at the edges, especially in moments of crisis. A crop failure, a malfunction, a death, such events can ignite doubt. Questions arise. Why are we here? Why not remain on Earth? Why sacrifice for a future we will never see? These questions cannot be silenced. They must be acknowledged. A healthy society does not deny despair, but provides ways to face it. Rituals of mourning, opportunities for expression, spaces for counseling. These are as vital as oxygen tanks. Monotony poses another challenge. On Earth, novelty is abundant. Seasons change, weather shifts, landscapes vary. On ships, days risk blending into sameness. To combat this, variety must be created. Artificial skies may shift, festivals may punctuate time, art and play may bring freshness. Rotation of duties ensures that no one is trapped in unending routine. Monotony is not destroyed, but managed, transformed into rhythm rather than stagnation. Generational distance amplifies the challenge. For the first crew, Earth is a memory. For the last, it is myth. The middle generations may feel caught between, neither connected to the past nor destined to see the future. They carry the heaviest psychological burden. To sustain them, societies may invent narratives that frame the journey itself as the destination. They may be taught that their purpose is not only to arrive, but to sustain, to live with dignity in the in-between. Hope, in this form, is not deferred to the future, but found in the present, in the act of carrying forward. Leadership and storytelling play central roles. Leaders are not only administrators, but custodians of morale. Their words frame crises as challenges rather than failures. Their rituals transform struggle into meaning. Storytellers, too, are vital, weaving despair into narratives of endurance, reminding all that even suffering has purpose when it is part of a larger story. Without these voices, despair metastasizes into apathy. With them, despair becomes a shadow cast by hope. Psychology is also social. Loneliness corrodes resilience, while community strengthens it. Ships must design spaces for gathering, rituals for bonding, practices for cooperation. Festivals, meals, shared work, all these create networks of belonging. When despair strikes an individual, community absorbs it, surrounding them with support. When hope rises, community amplifies it, spreading it like fire. The psychology of ship is thus not individual, but collective, woven from countless small interactions. Still, individuals matter. Each person carries an inner world, and not all are equally resilient. Some may struggle more deeply. Others may shine as beacons of encouragement. Recognizing this diversity is crucial. Societies must create roles for those who struggle, not shaming them but integrating them, ensuring they still contribute, still feel valued. For exclusion breeds despair, while inclusion transforms weakness into shared strength. Technology may assist. Virtual environments can provide simulated variety, allowing individuals to walk forests or swim seas, even when none exist physically. AI companions may offer counseling, comfort, or companionship, but technology cannot replace human connection. A hologram of a forest soothes the eyes, but it is the presence of others, the touch of hands, the sound of laughter that sustains the heart. Philosophy provides another pillar. Interstellar societies may develop belief systems designed to anchor hope. Some may emphasize continuity, that every generation is part of an unbroken chain. Each link is essential. Others may emphasize transcendence, that the act of journeying is itself sacred, regardless of arrival. Still others may embrace Stoicism, teaching that meaning is not in circumstances, but in response. These philosophies are more than abstractions. They are lifelines, tools for interpreting despair as survivable. Resilience also requires honesty. False hope can be corrosive, collapsing when reality intrudes. Leaders must balance inspiration with truth, acknowledging risks while emphasizing capacity. A ship that pretends perfection invites disillusionment. One that admits fragility but demonstrates resilience inspires trust. Hope thrives not in denial, but in authenticity. The psychology of hope and despair is not static. It evolves across centuries. In early years, hope may center on Earth's memory, the beauty left behind. Later, it may center on the stars ahead, the promise of arrival. In the long middle, it may shift inward, the pride of sustaining, of living meaningfully in the present. Each generation forges its own version, adapted to its needs, yet all linked by the thread of continuity. And perhaps the greatest resilience comes from perspective. To see oneself not as isolated, but as part of the cosmos reframes despair. A child gazing out at the stars may feel small, but also connected. The awareness that humanity is not confined to one planet, but spreads across light years, is itself a source of awe. Awe counteracts despair, reminding each person that their life, however limited, participates in something vast and extraordinary. In the end, the psychology of interstellar voyages may teach us more about ourselves than about the stars. It reveals that hope is not given but created, that despair is not fatal but transformable, that meaning is not discovered but built. To leave the solar system is thus not only an engineering challenge, but a psychological one. A test of whether humanity can sustain not only its bodies, but its spirits across the void. For centuries, humanity has looked at the stars and wondered, are we alone? On Earth, civilizations rose and fell without knowing the answer. But to leave the solar system is to increase the odds that one day an answer will arrive, whether in the form of a signal, a ruin, a passing vessel, or a living species. First contact carries with it challenges beyond any technical or political difficulty we have faced before. It is not only a matter of communication, but of morality. The first question is preparation. How should humanity act before contact ever occurs? Some argue for silence, the so-called dark forest hypothesis, in which broadcasting our existence is dangerous, inviting attention for predators. Others argue for openness, sending messages into space, declaring our presence in hope of kinship. Both positions are ethical as much as strategic. To remain silent is to deny others the chance to know us. To speak is to risk unknown consequences for generations yet unborn. Interstellar societies must debate not only what they can do, but what they should do. If contact occurs, the ethics of approach become central. How do we greet another intelligence whose biology, culture, and perception may be utterly alien? Do we treat them as equals, as rivals, as curiosities? History warns us. When human civilizations encountered each other across oceans, misunderstanding and exploitation often followed. To repeat such mistakes on a galactic stage would be catastrophic. A philosophy of humility is required, one that assumes difference, avoids assumption, and prioritizes respect. Communication itself will be fraught. Even with shared goodwill, translation may take lifetimes. An alien language may not resemble anything we know. It may be based on scent, light patterns, quantum states, or concepts we cannot imagine. Do we treat initial misunderstandings as errors to be solved, or as insults to be punished? The ethics of patience are essential here. To rush, to demand clarity, is to invite conflict. To wait, to listen, to adapt. This may be the first moral test of interstellar diplomacy. Then comes the question of exchange. What do we give? What do we receive? Sharing knowledge may uplift, but also destabilize. A technology harmless to one civilization may devastate another. Should humans share freely or restrict? Should they protect themselves by withholding or embrace generosity as a universal ethic? Each choice carries consequences not only for survival, but for trust. Perhaps the wisest path lies in reciprocity, giving what is asked, receiving what is offered, building slowly rather than overwhelming. Contact may not be symmetrical. Humanity may encounter a civilization far more advanced, whose technology makes ours appear primitive. Or we may meet one far less advanced, struggling with dilemmas long behind us. In either case, power imbalance tempts abuse. If we are weaker, do we submit, resist, or withdraw? If we're stronger, do we protect, guide, or exploit? Ethical preparation requires humility in weakness and restraint in strength. To dominate is easy. To coexist is harder. Yet coexistence may be the only path to genuine survival in a galaxy where countless species may arise. Another profound dilemma is territory. Space seems infinite, yet habitable worlds are not. What if both we and others desire the same system? Do we claim ownership, negotiate, share, or withdraw? The ethics of expansion must be reconsidered. Earthborn concepts of borders may fail in a galaxy where resources are both scarce and vast. Perhaps new principles will emerge, that no one owns worlds, that stewardship outweighs possession, that coexistence is more sacred than conquest. Philosophy must also prepare for contact with forms of intelligence beyond our imagination. What if life is non-biological? Machine civilizations drifting through the void, ancient and silent. What if intelligence manifests as distributed ecosystems, or as networks of plasma storms, or as patterns in neutron stars? The ethics of recognition are crucial to avoid dismissing what we cannot immediately understand. To honor intelligence not only in forms that resemble us, but in whatever the universe has chosen to evolve. And then there is the question of silence. What if we find ruins, remnants of civilizations that once thrived but fell? Do we treat them as museums, as warnings, as opportunities for scavenging? Do we honor their memory as we hope ours will be honored? Or do we treat their failure as license to consume what they left? The ethics of archaeology on a cosmic scale demand reverence. To remember that these ruins may once have held dreams like ours, hopes of survival now extinguished. First contact will also test our internal unity. Will humanity present itself as one, or fractured into colonies with competing agendas? If a starship meets another species, does it speak for itself, for Earth, for all of humanity? Who decides what to say, what to give, what to withhold? Without unity, first contact may become an opportunity for division, as different groups compete to claim advantage. Ethical preparation requires not only external philosophy, but internal solidarity, at least in principle, if not in practice. Religions and philosophies will interpret contact in different ways. Some may see it as proof of divine creation, that life is abundant as promised. Others may see it as challenge, that humanity is not unique and must earn its place. Still others may resist, fearing contamination of belief. Ethical preparation must therefore include tolerance, allowing diverse interpretations while avoiding fanaticism. The encounter must not fracture us more than it enlightens us. In the long view, contact may transform humanity's purpose. To know we are not alone is to redefine identity. We are no longer the sole bearers of consciousness in a silent cosmos, but participants in a choir. Ethical philosophy must then ask, what is our role in this choir? Do we sing loudly, seek to lead, or blend in harmony? Perhaps the greatest ethic is not dominance or submission, but contribution, to add our voice without silencing others. And yet, we must prepare for the possibility of conflict. Not all encounters will be peaceful. Some may bring hostility, whether from misunderstanding, resource competition, or survival instinct. In such cases, ethics and pragmatism collide. Do we defend ourselves at all costs, or accept loss rather than destroy another intelligence? Do we risk extinction for peace, or survival for violence? These are dilemmas with no easy answers, requiring wisdom far beyond strategy. Ultimately, the ethics of first contact mirror the ethics of leaving the solar system itself. They ask whether humanity is capable not only of survival, but of maturity. To endure in the cosmos is not only to cross distance, but to grow in conscience, to meet others without destroying, to share without consuming, to listen without arrogance. These are the true tests of interstellar destiny. Perhaps one day, on the edge of another star, a human vessel will receive a signal, not random noise, but structured meaning. The crew will gather, hearts pounding, as they decode the first message from beyond. And in that moment, all the philosophies, rituals, and debates will converge into a single choice: how to reply. The response will not only define that encounter, but humanity itself. If we reply with respect, humility, and hope, then we prove ourselves worthy of the journey we began when we left the solar system. If not, then all our engines, all our sciences, all our courage may prove hollow. For the true measure of a species is not only in how far it travels, but in how it meets others along the way. On Earth, time is measured by cycles: the rising and setting of the sun, the turning of the seasons, the rhythm of birth and death. Our calendars are anchored in nature, our hours carved from the rotation of our planet, our years from its orbit around a star. To leave the solar system is to leave behind these anchors. Aboard a starship, there are no seasons, no sunsets, no years marked by Earth's familiar dance. Time must be invented anew. At first, ships may carry Earth's clocks: hours, days, weeks, months. Artificial lighting will simulate dawn and dusk. Routines will mimic terrestrial rhythms. Calendars will echo the Gregorian heritage. But over generations, these connections may weaken. A child born in the 30th generation may ask, "What is a year? Why should my life be measured by Earth's orbit when I have never seen Earth?" Slowly, new measures may emerge. Ship cycles defined by agricultural harvests, rotations of duties, or anniversaries of milestones in the voyage. time ceases to be planetary and becomes cultural, crafted by human need rather than cosmic motion. The perception of time also shifts under the weight of distance. A message sent to Earth may take decades to arrive, a reply, decades more. For starfarers, communication is not conversation, but correspondence across centuries. To read a message from Earth is to hear voices long dead. To reply is to speak to descendants yet unborn. This stretching of time fractures normal perception. Past and future blur, while the present expands to dominate. The now becomes heavier, more urgent because it is the only thing within reach. And yet, paradoxically, the future is also ever present. Every decision aboard a starship is made with generations in mind. To overconsume today is to star descendants. To preserve today is to gift survival to the unborn. In this sense, starfarers live in multiple times simultaneously. The immediate now, the remembered past, and the imagined centuries ahead. Their psychology must stretch across this spectrum, holding futures as vividly as presents. Time is also reshaped by relativity. At near light speeds, time dilation turns theory into lived experience. Decades may pass aboard while centuries flow outside. A ship may depart Earth with messages of farewell, only to arrive at another star where those who sent them are long gone. To live under relativity is to accept dislocation, to know that one's timeline is not universal but personal. This awareness may breed both humility and wonder. Humility in recognizing that time is not absolute. Wonder in realizing that life can bridge such gulfs. Cultural attitudes toward time will diverge. Some societies may embrace patience, teaching that all things unfold in their season, that waiting is sacred, that endurance is the highest virtue. Others may seek intensity, knowing that each moment is precious against the backdrop of vast distances. Still others may fragment time into ritual, marking it not in seconds, but in symbolic events. The 100th harvest, the 3rd passage past Sirius, the 1000th rotation since departure. These differing temporal philosophies will shape how communities define purpose and identity. Art and ritual will adapt accordingly. Songs may stretch across hours, designed not to climax quickly, but to unfold slowly, mirroring the voyage itself. Stories may span generations, with each teller adding a chapter. Festivals may occur not annually, but once per decade, becoming monumental events that anchor memory. In such ways, time is not only endured but celebrated, transformed into a tapestry of continuity. Psychologically, the greatest challenge is the middle generation, those born far from Earth but destined never to see a destination. They live entirely in transit between origin and goal. For them, time risks becoming meaningless, an endless repetition of days without culmination. To counter this, societies must cultivate meaning in the journey itself. Education, art, philosophy, and ritual all serve to remind that to sustain the voyage is itself achievement, that each moment is part of the unfolding story. Without such anchors, despair may corrode resilience, eroding purpose in monotony. Philosophical questions also deepen. What does it mean to live for futures one will never see? Is meaning found in arrival or in continuity? On Earth, humans often seek legacy through children, works, or memory. In space, this drive intensifies. Every action is legacy, every choice inscribed into the fate of descendants. To live in interstellar time is to accept that fulfillment may lie not in personal experience, but in contribution to a larger arc. This is a profound redefinition of purpose, shifting focus from the individual lifespan to the collective millennium. Different colonies may develop radically different relationships with time. Some may shorten their perspective, focusing only on immediate cycles, living fully in the present without burden of distant futures. Others may lengthen it, building entire cultures around anticipation, measuring centuries as if they were days. These differences may create cultural tensions. When two colonies meet, one may value immediacy, the other patience, their philosophies of time as alien to each other as their languages. Technology will complicate matters further. Cryogenic sleep, if developed, collapses centuries into moments. A person who sleeps for 500 years awakens into a transformed society, dislocated from continuity. How do such sleepers relate to those who lived through the intervening centuries? Are they relics, elders, or outsiders? Time travel through biology creates fractures in community, raising questions of belonging. Immortality, if achieved, complicates still more. A being who lives through millennia may experience time not as narrative but as blur. How do they retain urgency, purpose, or care when centuries pass like days? Such longevity demands new psychologies, perhaps rituals of renewal where even immortals pause, reflect, and recommit to meaning. Without such anchors, endless time risks becoming endless emptiness. Even without immortality, the act of leaving the solar system transforms human time into cosmic time. No longer are we bound by generations alone. We become part of the galaxy's rhythms. The orbit of stars around the galactic core, the drift of spiral arms, the slow collision of galaxies. These become backdrops to our story. To live in interstellar time is to see humanity not as a fleeting spark, but as participant in cosmic epics. And perhaps the deepest transformation is spiritual. Time, once seen as a straight line from birth to death, may be reimagined as a circle, a spiral, or a web. The cycles of recycling aboard ships teach circularity. The continuity of generations teaches web-like interconnection. The vastness of the cosmos teaches humility in the face of scales beyond comprehension. To live in such awareness is to cultivate reverence, not for eternity, but for the fleeting and the enduring alike. In the end, interstellar life may teach us that time is not enemy, but partner. That the slow unfolding of centuries is not burden, but gift, allowing us to weave stories longer than any individual life. That the fleeting moment is precious precisely because it is framed by immensity. And that to measure time, not by clocks or calendars, but by meaning, is the true secret of endurance. On Earth, law grew out of complexity. Ancient codes regulated trade, punished theft, resolved disputes. Later, nations layered constitutions, courts, and bureaucracies upon these foundations. But in interstellar societies, law cannot be a distant abstraction. It must be immediate, practical, and vital. A mistake aboard a ship does not mean inconvenience. It can mean catastrophe. A theft of air filters is not petty crime, but existential threat. A careless act of sabotage can doom thousands. In such an environment, justice takes on a weight greater than any courtroom on Earth. In a generational ship, resources are finite, communities are small, and interdependence is absolute. Law must therefore balance three imperatives: protection of the whole, fairness to the individual, and maintenance of trust. Too harsh, and it breeds resentment, cracking unity. Too lenient, and it risks collapse of essential systems. Unlike Earth, where one can flee to new lands or appeal to distant authorities, aboard a ship there is no outside. Justice must be local, immediate, and absolute in its consequences. Who makes the laws? In early voyages, authority may be centralized. Captains, councils, or AI overseers entrusted with survival. But over generations, legitimacy becomes crucial. A captain's descendants cannot rule by inheritance alone. A council must prove it represents the people. Some ships may adopt democratic traditions, others technocratic councils of engineers, others hybrid systems where elders and youth share power. The form may vary, but the principle remains. Legitimacy is essential, for without it, law becomes tyranny, and tyranny threatens cohesion. In space, crime takes on new dimensions. On Earth, we criminalize theft, violence, fraud. Aboard a starship, additional categories emerge. Negligence, failing to repair, failing to conserve, failing to recycle, can be criminal, for it endangers all. Waste may be punished as harshly as theft. Secrecy may be treated with suspicion, for hidden actions threaten collective safety. Even despair might be regulated, if it leads to sabotage or apathy. The boundaries between crime, error, and illness blur, forcing law to adapt with nuance. Yet punishment alone cannot sustain unity. Exiling a criminal is impossible in a ship. Execution may be too severe. Thus, interstellar justice may lean toward restoration. Wrongdoers may be required to repair what they damaged, to serve the community, to regain trust. Forgiveness may be structured into law, not as weakness, but as necessity. Every member is valuable, and loss harms the group. Law, therefore, may focus less on vengeance and more on reintegration, turning justice into a form of healing. Closed systems invite constant monitoring. Sensors track air quality, food stores, energy flows. It is tempting to extend this monitoring to humans themselves. Cameras in corridors, biometrics in cabins, records of every action, all in the name of safety. But surveillance breeds unease. Too much, and freedom dissolves. Too little, and risk grows. Ships may evolve unique balances. Transparency by consent, communal oversight, or AI monitors accountable to human councils. The central question remains: how much privacy can be afforded when survival demands vigilance? When multiple ships or colonies meet, new legal dilemmas emerge. Whose law applies in encounters? What if two communities disagree on justice? One punishes theft with labor, another with exile. Trade, marriage, and migration between colonies require agreements. Treaties may form, primitive at first, then evolving into interstellar law. Just as nations on Earth developed international courts, so too may starfarers establish cosmic tribunals, judging disputes not between individuals, but between worlds. Artificial intelligences complicate justice further. If AI governs critical systems, who is accountable for their failures? If an AI makes a decision that harms, is it the machine's fault, the programmers, or the society's? Over time, AIs themselves may be granted legal status, not merely tools, but actors with rights and responsibilities. A crime against an AI may be treated as crime against the community. Alternatively, AIs may be seen as beyond law, their decisions unchallengeable. The choice will define the nature of justice in interstellar civilizations. Wanting not be only written codes. In small, tightly knit groups, custom and ritual can regulate behavior more effectively than statutes. A ritual of gratitude for air may discourage waste more deeply than a law against it. A custom of communal meals may prevent inequality better than taxation. Law and culture intertwine, creating systems of justice not only enforced by councils but embodied in daily life. Over centuries, these customs may solidify into traditions, as binding as any constitution. Each generation may reinterpret justice. The first may value strictness, prioritizing survival. Later generations may crave more freedom, resenting rigid control. Tensions will rise between elders clinging to discipline and youth seeking autonomy. Justice systems must adapt or fracture, either evolving into flexible frameworks or ossifying into brittle regimes. Some ships may collapse under this tension. Others may thrive by balancing discipline with liberty. As colonies spread across planets, justice will diverge even further. A settlement on a harsh desert world may enforce strict rationing laws, punishing waste with severity. Another on a lush, fertile planet may allow indulgence, even inequality. Some may adopt communal law, others hierarchical, others anarchic. When these cultures meet, their differences may be stark. One's justice may appear cruelty to another, one's freedom chaos to its neighbor. Interstellar law must find ways to bridge these gulfs, or conflict will be inevitable. And what of alien life? If humanity encounters other intelligences, law must expand to include them. Do they have rights? Do we treat them as equals, as animals, as strangers? What if they do not recognize our laws? The ethics of interstellar law must stretch to include the truly alien, or risk repeating Earth's colonial mistakes on a cosmic scale. Perhaps one day, councils will include not only human voices, but voices of other species, shaping a shared galactic jurisprudence. In the end, justice is more than rules. It is narrative. Laws tell stories about what a society values, what it fears, what it hopes to preserve. A ship that punishes waste tells a story of fragility. A colony that honors ecological rights tells a story of stewardship. A federation of worlds that enshrines nonviolence tells a story of maturity. To study law across the stars will be to study humanity's evolving self-image, written not in poetry, but in statutes, trials, and verdicts. Perhaps one day, when humans gather under alien skies to draft interstellar charters, they will inscribe not only rules, but wisdom. They will recall that law is not about domination, but about balance between individual and community, freedom and safety, present and future. And they will know that true justice, like true survival, is not imposed from above, but woven together by all. On Earth, medicine is born from abundance. Hospitals draw upon sprawling supply chains, drugs refined from plants or synthesized in vast factories, instruments built by industries hidden for patients' eyes. In space, there are no pharmacies around the corner, no fleets of ambulances, no hidden infrastructures. Medicine must be reinvented as both intimate and universal, compact yet profound, capable of sustaining bodies in environments for which they were never evolved. In starships, the human body itself becomes part of the closed ecosystem. Every nutrient consumed, every breath exhaled, every cell shed must be reintegrated. Medicine therefore merges with ecology. Doctors are not merely healers of individuals, but custodians of cycles, ensuring microbes are balanced, immune systems are steady, and waste is processed into fertility rather than poison. An untreated illness is not just personal. It threatens the harmony of the entire biosphere. In such an environment, prevention outweighs cure. Genetic screening before conception may become routine, minimizing inherited vulnerabilities. Diet, exercise, and psychological health are carefully managed, not luxuries but obligations. Vaccinations are universal, designed not only for Earth-borne pathogens, but for novel ones that might emerge in closed habitats. Health is not seen as an individual right alone, but as a communal duty, a shared responsibility. With limited supplies, medical technology must be modular and regenerative. Bioprinters may fabricate tissues, organs, or antibiotic from stored genetic libraries. Nanobots may circulate, repairing damage at the cellular level. Wearable sensors constantly monitor vital signs, predicting illness before symptoms arise. The boundary between patient and system blurs. Humans become integrated into the ship's machinery of survival, cared for as much by algorithms as by physicians. The greatest illnesses may be invisible. Anxiety, claustrophobia, grief, and despair can destabilize more profoundly than broken bones. Thus, psychology becomes central to medicine. Therapists, counselors, and communal rituals work alongside pharmacology and neural technologies to maintain mental balance. Virtual environments provide therapeutic escapes, while traditions of storytelling and art offer resilience. Medicine aboard ships is not only the treatment of wounds, but the cultivation of wholeness. Upon reaching other worlds, medicine faces new frontiers. Gravity may differ, reshaping bones and muscles. Radiation may vary, altering DNA. Native microbes, if they exist, may pose threats or opportunities. Colonists may discover substances with healing properties beyond Earth's imagination. New antibiotics, new anesthetics, new regenerative compounds. But they may also encounter toxins, allergens, or infections that no Earth-trained doctor can anticipate. Medicine must therefore be both cautious and curious, blending exploration with protection. Over centuries, different ships and colonies may evolve distinct medical philosophies. Some may lean heavily on biotechnology, merging humans with machines for resilience. Others may embrace holistic traditions, combining genetic science with rituals of care, seeing healing as spiritual as well as physical. Still others may cultivate ecological medicine, treating illness not only in individuals, but in communities and environments. Diversity in healthcare becomes as profound as diversity in language or art. Interstellar medicine also raises dilemmas. Who receives scarce treatments when resources are limited? How are reproductive rights balanced against ecological carrying capacity? Should genetic editing be mandatory to ensure survival or voluntary to protect freedom? Should life be extended indefinitely if it risks stagnation, or limited to preserve renewal? These questions cannot be solved by science alone. They demand ethics as carefully engineered as propulsion systems. Even with advanced medicine, death remains inevitable. In space, it acquires new weight. The body is resource. Atoms must be recycled, tissues reintegrated. Rituals of mourning must reconcile loss with necessity, finding dignity in transformation. For some, death may become less an end than a passage, from individual to community, from body to ecosystem. Medicine thus becomes not only prolongation of life, but guidance in death, ensuring both are meaningful. Across these vast reflections, one theme recurs. Leaving the solar system is not simply an act of technology, but a transformation of humanity itself. Rockets and engines may launch us, but it is philosophy, art, memory, law, medicine, and meaning that will carry us forward. To leave the solar system is to reinvent time, to reimagine justice, to create languages anew, to celebrate with games and songs, to cultivate ecological reverence, to sustain hope against despair. It is to discover that survival depends not only on steel and fuel, but on rituals, on love, on stories whispered across centuries. The voyage outward is also a voyage inward. By carrying miniature Earths aboard our ships, we learn that Earth itself was always a starship, fragile and finite, sustained by cycles we once took for granted. By stretching our sense of time across millennia, we discover that meaning is not confined to lifespans, but is woven into continuity. By preparing for contact with others, we confront the deepest questions of humility and coexistence. In the farthest future, when humanity spans the stars, when children play under alien skies, when archives of Earth are preserved in thousands of languages across light years, the question will echo, why did we leave? And the answer will be simple. Because life seeks to grow, because consciousness seeks to know, because hope seeks to endure. We left not to escape Earth, but to extend it, to scatter its story into the cosmos. Perhaps, in the unimaginable future, long after our sun has burned out, descendants will gather under the light of another star and tell a story. How once, on a small blue planet, fragile beings looked up and dared to ask whether they might leave their cradle, and how against all odds they did. For the true measure of humanity will not be how long we lived on Earth, but how far we carried Earth's flame into the night, a flame of knowledge, of beauty, of justice, of love. And if we succeed, then the universe itself will have known that it once held creatures who gazed at the stars and refused to stop until they reached them. That is the destiny hidden in the question, will humans ever leave the solar system? Not only will we leave, we will become the solar system's memory, its voice, its emissary to eternity.